हाँ हाँ दोस्त ओके आई गिव यू वो पीपीटी भेजा आपको ना डेटा डेटा निकालना है ठीक है एसपीओसी आंसर को डालने के बोले ना एसपीओसी आंसर को डालने बोल रहे ना बोले सर हमको भेज दिया हूं मतलब सर मेल करती हूं मेल करती है वो भी मेरे पास नहीं है नहीं वो भेजा किसका है पीडब्ल्यूसी कर रहा है आंसर तो भेजा बोला ना वो हां हां बोला लेकिन जो भी ऑपरेशन का डेटा था मोस्टली संदीप से लेना है दिक्कत हुई है ना इन लोग को नाम डालने पे मौत आती है तो ये सब नाम डालो ना भाई आदमी का जब दे रहा है तो वेरी गुड बैंक किधर है ये अपना कंपनी का जो भी चाहिए देख सबसे पहले कॉल कहाँ आता है वे ब्रिज में आएगा है ना वे ब्रिज से वेमेंट होगा वेमेंट होने के बाद कहाँ आएगा ट्रैक हॉपर में आएगा ट्रैक हॉपर में अनलोड होगा ठीक है ट्रैक हॉपर में क्या है नीचे हॉपर्स रहते हैं उसमें कलेक्ट होगा फिर कन्वेयर बेल्ट के थ्रू आगे कन्वेयर होगा उसके बाद ट्रैक हॉपर के बाद जो मेजर इक्विपमेंट है वो दैट इज प्रेशर प्रेशर में कोल्ड प्रेस होगा अब प्रेशर से या दो जगह जा सकता है वो या तो डायरेक्ट फीडिंग होगी है ना या फिर होगी स्टैकिंग है ना अब स्टैकिंग अगर किया है तो वो वापस से क्या होगा रिक्लेम होगा रिक्लेम होगा ठीक है ये दोनों चीजें जो है सेम ही है रिक्लेम हो चाहे डायरेक्ट फीड हो ये दोनों कहाँ जाएगा ये जाएगा बंकर में है ना बंकर में जाएगा बंकर में स्टोर होगा बंकर के बाद ये जाता है कोल्ड फीडर में ठीक है कोल्ड फीडर से जब हम लोग इसको फायर करेंगे फाइनली तो ये कहाँ जाएगा बंकर से मिल फीडर एक ही चीज है मिल में वो और बारीक होगा पिसाएगा है ना फिर फीडर के थ्रू फीड हो जाएगा वहां से फिर जाएगा बॉयलर है ना तो ये बॉयलर में जो जाता है उसको हम लोग बोलते हैं फायर ठीक और यहाँ जो हमको रिसीव हो रहा है इसको बोलते हैं रिसीव हाँ अब क्या होता है क्वालिटी में ARB होता है और होता है ADB ठीक है ARB क्या होता है रिसीव्ड बेसिस ठीक है और ADB क्या होता है राइट बेसिस है ना तो रिसीव्ड बेसिस का मतलब क्या होता है जिस कंडीशन में कॉल आया है सेम कंडीशन में उसका एनालिसिस ठीक है अब उसको क्या है एक पर्टिकुलर टाइम के लिए एयर ट्राई करेंगे नॉर्मल छोड़ देंगे उसको फिर से उसका एनालिसिस करेंगे इन दोनों प्रोसेस में डिफरेंस क्या आता है कोल में दो टाइप का मॉइस्चर होता है TM एंड IM ठीक है तो TM जो होता है ना दैट इज एक्सटर्नल मॉइस्चर सरफेस मॉइस्चर और IM जो होता है ये होता है इनहेरेंट मॉइस्चर हाँ तो जब उसको एयर ड्राई करते हैं या खुले में उसको हम लोग सुखा देते हैं तो ये जो सरफेस मॉइस्चर है ये टोटल मॉइस्चर है ये निकल जाएगा ठीक है अब इसके बाद एयर ड्राई होने के बाद ये IM जो है ना ये बचेगा तो इस ये दोनों में डिफरेंस आता है इसलिए GCV जो है दोनों पे डिफरेंट रहेगा तो हम लोग ये वाला जो एज रिसीव्ड बेसिस वाला इसको यूज करते हैं हर जगह पे, चाहे वो फायर्ड हो चाहे रिसिप्ट हो।
ये एयर ट्राई नहीं करते उसको छोड़ के तो
एयर
जाते हैं।
ट्राई भी करते हैं,
हाँ।
एयर ट्राई करके उसके बाकी पैरामीटर्स निकालेंगे। इनहेरेंट मॉइस्चर निकालना है तो कैसे मिलेगा, वो एयर ट्राई करने के बाद एनालिसिस करते हैं। इसलिए जब तू रिपोर्ट देखेगा तो दो साइड में, इधर पे रहता है एडीबी और इधर रहता है एआरबी। ठीक है, इसका फुल एनालिसिस का एक प्रोसीजर है, तो वो तुझे शेयर करूंगा, वो पढ़ना तो और क्लियर होगा।
It's another eventful day,
अभी
Jindal Institute of Power Technology. As you are aware that JIPT is the training arm of Jindal Power Limited, and we used to organize various workshops and seminars for the benefit of power plant professionals
एक बार थोड़ा बना
and
लेता हूँ।
technocrats. And this time we have come up with the topic of flexibilization, technological solutions, and O&M practices in power plants. And this is an most important topic of today's interest, because as you are aware that, as our senior has pointed out, that the India has gone for the ambitious goal of adding around 500 gigawatt power of renewable sources. It ultimately pushes us to go for accepting these renewable. Troubles in the existing system, because the renewable energy has to be accepted and adopted in the existing grid system, and it is a reliable and it is inconsistent. So we hope to look for some opportunity, and reason means how these renewable energy sources can be accommodated in our grid system, and how our coal-based plants can be operated in the minimum technical. So this workshop will serve us various options and technological solutions, how this can be implemented in a best way to keep the power plants in sustainable and more efficient manner. So with this workshop has been arranged with a 4-session technical session by inviting experts from the various power plant. Apart from the speakers, there are a lot of power plant experts are have joined physically as well as through online mode. So they will be also interacting during this discussion, and they will be sharing their valuable suggestion how to go ahead about the challenges what we are currently facing. So the morning session starts with the Jindal Power Limited, which will be sharing their experiences in flexibilization and the valuable solution in bringing how these O&M practices can be modified, altered to cope up with these minimum technical load demands. So on behalf of you, I invite Mr. Rajesh Singh, AGM Operation, as well as Mr. Sandeep, Manager, to present the presentation on JPL practices of flexibilization and their valuable solutions. Okay. And both the engineers are from operation side, having a vast experiences in the operation. I am also more excited like you to listen their experiences. Sir, please come on stage and present your case studies.
Thank you, sir. Welcome, all dignitaries. Already much has been said about the flexibilization. And flexibilization is a pretty much familiar term now. If someone would ask me what is define flexibilization, then I would answer it is a opposite of rigidity. Then if someone would ask me, are you flexible as a power producer? Yes, I am flexible as a power producer because I'm already operating my unit from my base load operation.
On the other hand, you tend to feel like that.
55%, 50%. So we are flexible. But due to some compliances, we are forced to push down below 55 or 50% operation to 40%. And the window is very narrow. As I said, 55% to 40%, the percentage difference is very less. That is 15%. But the single equation lies between this 55% and 50%. Because when we operate our unit at 50% of 50% load condition, this is one common challenges that we will discuss in for the next model.
अभी इस वाले में डाल देना पड़ेगा ना नहीं इस वाले
वॉइस क्लियर नहीं है
I suppose are the major concern area. So calculate where you stand. What is your position in your current situation? We have been given the opportunity to operate our unit at 40% load also. Once we got the opportunity to operate our 40%, that too not intentionally, but we were shutting down our unit. That was a forced shutdown, and we have taken that opportunity to extract some parameters from that 40% operation. That will help us in our future consideration that what are the challenges in that 40% operation we have faced. So before starting this presentation slide, I would share our case study for 50% load operation and 40% load operation that we have done already in our unit for just pilot analysis, that what are the problems we have faced and what will be the problem we will be facing in near future. This report we have framed for the 50% load operation, and the challenges are being explained in this report only. When we have operated our unit in 50% load operation, this is the small data information about our unit. The boiler type is PF boiler. Firing system is our tangential. Mills we are operating 4 at a time for base load operation, and for part load operation we reduced it to 3 mill operation. ID fan, FD fan, PF fan are operating at 2 into 60% MCR. Economizer type is plain tube type. Push down करना. So as the four points suggest, cold startup to full load, we have taken the data from cold startup to full load just for the seeking condition that what is our ramp rate, which we are comfortable in right now. Ramp down from full load to low load, that is 250 megawatt to 138 megawatt. Ramp up from low load to full load, 140 to 250, and for MTL operation of 51% loading condition. Zoom. Okay. Am I audible? Operating data has been collected for the span of every span trend analysis of 30 seconds. We have shrink it down to 1 minute operation, 1 minute data. And the data we have extracted from the conditions are load, O2 values, NOx, CO, down up here, mean steam temperature, reheat temperature, superheated steam temperature, mill loading, flame scanner intensity, burners, drum level, metal temperatures. That is NTM.
Sorry for interruption. I'm calling
These are the questions we should ask from ourselves just to analyze that where we are standing, what our condition and what our system demands. With the aging, the challenges become, with the aging of machines, the challenges become even more. But these are the questions that what prevents from operating at lower load. 100% of the cases, I suppose, flame instability is the one reason. What consider as the main problem during minimum load operation? Flame stability. Again, use of kernel till to reduce main steam temperature during ramp ups. Yes, we do. In auto also. Can flame scanners influence the ability to operate at lower loads? Yes, it does. Flame scanner is a challenge. How do flame scanners influence the ability to operate at lower loads? Flame intensity gets decreased considerably during lower loads. Means if you are operating your system at say 60% operation, 60% load operation, or 250 megawatt, say 150 megawatt. The average flame intensity we get is around 60%, 55 to 60%. But if you go down to 50% or 45% operation, the average flame intensity decreased from 65 to 55 to 65% to 45% to 55%. And in some corners, even low. And it should be more than 35%. So these are the conditions that we have framed for the case study. We have already taken data for the 51% MTL operation, and we were very much comfortable in this operating condition. Not much of a challenge we found in this condition, but the challenge occurs when we reduce the load from 51% to even low load, that is 40% operation. That was opportunity based. I say it again, it was an opportunity based operation, not intentional operation. It was an opportunity based operation that we were shutting down our one of the unit of the 250 megawatt, and we have taken it as opportunity to set up our behavior analysis for operating the unit at 40% operation. इसको बंद करके assessment. These are the pre-test data. Load condition at March 27-22. We have extracted this data, and you can see the parameters decreasing from base load operation to low load operation. The trend itself is signifying that the parameters are decreasing in a decreasing trend. दिखाते जाओ ऊपर बढ़ा देगा स्लाइड पे. This is the trend of ramp up time. Load ramp up condition. 55% to 100% MCR, 0.8% per minute is where we are standing in right now, and we have to go to 3%. The challenge is from 8% to 3% ramp up operation or ramp down operation. The changes in the main steam superheater outlet deviation, you can see it very well, 528 degrees to 547 degrees Celsius. HRS temperature deviation also. In these parameters, we can easily analyze that there is not much of a problem regarding temperature issue. ऊपर करना और ऊपर करना और ऊपर करो और ऊपर करो और ऊपर करो बस. What were the findings? There is a sharp increase in rate and metal temperature at the beginning of the load ramp. At the same time, the hot rate temperature is increasing slightly. The burner tilts are reacting in a controlled manner, but there is a scope of fine tuning as the metal temperature rise found to be approximately 20 K during initial ramp up period of 1 hour. This indicates that the burner tilt further tuning required. The whole analysis and the conclusion of that particular trend is that the burner tilt operation needs tuning. There comes the loop tuning operation challenge. You have to tune your loop in a more idle manner so that the fluctuation should not be more than 5 degrees plus minus per minute. Now the second challenge was drum level. Drum level fluctuation was observed to be much more sharper than the other parameters at low load conditions. There again, loop tuning is required. Or if I say what is the solution? So the solution right now is a uni drive operation. In normal condition, we use 2 BFPs for our loading operations. But in this case, I should suggest that there should be a uni BFP operation. It is clearly indicated that during load ramp up, drum level is in concurrence with feed water flow has not been a concerning one. The drum level only oscillating between -30 to +10 yet during load ramp ups. But problem lies when load ramp down is introduced. It is clearly indicated that during load ramp down, drum level oscillations got prominent once load approaches less than 145 megawatt, which is a prognosis condition for even lesser load. This is a concerning one. Wind box, as I say, out of the 3 conditions, wind box DP is also a major concern for us at low load operations, apart from drum level and flame intensity. Wind box differential pressure 40 to 50 mm of WC is another challenge to look after, as during ramp downs, excess air percentage got increased so as to avoid air rich condition. Secondary air flow needs to be optimized, resulting in lesser furnace and 2 wind box delta P. This is the condition of 51% MCR. And look at the flame intensity data. It is going down, but it is going down lesser than 30% at some corners. This is our next concern. So at 51% loading condition itself, we have investigated some data and we came to the conclusion that steam temperature control at low load is one concern. Drum level control at low load is another one. Flame stability and furnace pressure DP. And apart from this, low flue gas temperature at low load. Low flue gas temperature will directly hamper the burning or ignition of fuel coal at lower loads. इसको बंद करके word वाला कैसा कर थोड़ा सा नीचे करना बस. On 17th of March, we have got the opportunity to shut down our units, and we have taken it as opportunity to operate our unit at 40% loading condition, and we have extracted some of the data, and also we have sustained the unit for 40 minutes at that loading condition without any oil support. And the analysis report is further explained. These are the parameters we have taken. The data for first assay, airflow profile, flue gas profile, stream flow profile, MTM, feed water flow profile, SADC, mill profile, flame intensity, fan profile, and APH profile. It might have covered all the areas of boiler, I suppose, at lower loads. And the data extracted for 30 seconds span. We have minutely observed all the parameters in this condition, and we have framed this report. The challenges are same. Again, drum level, flame intensity, and wind, furnace to wind box DP. But we managed to operate that unit at 40% load, and we came to the conclusion that if we manage to cater these three conditions, then it is very much possible to operate that unit in 40% for longer periods. Reports दिखा दें, report दिखा दें, और हाँ ये वाला टेबल दिखाना. This is a running parameter, minimum, maximum, and average. And what should be the proposed one? Proposed one, because we have analyzed this data at 40%, and when we came to the conclusion that what should be the parameter around which we should operate the unit, so that a 40% loading operation is possible. Like load minimum we achieve we gone up to was 95 megawatts. Maximum at that proposed time, that 40 minutes span, was 111 megawatt, average 103 again. And what should be proposed? Our target is 100 megawatt, that is 40%. Total airflow minimum we achieved was 508 tons. 668 was the maximum one, because we were reducing that time load. What should be the stable airflow? That comes around 630, 620, 630 range. Proposed one, 560. That is the minimum possible tonnage of air that we can manage. Secondary air, left and right combination segregation has been shown. O2 percentage has also been there, and range has also explained what should be the proposed range, 6.5 to 7.5 for stable load operation. Primary air 188, we cannot go less than 180, that too in unit drive operation. We cannot manage it by 2 PFN operation. 2 PFN will again introduce a problem of PFN stalling, because we have a parallel PFN operation. So there comes the condition when we reduce the PA header, then the flow will come into the situation of 220 to 10 ton per hour, below which the PFN gets unstable. So we propose for a unit drive operation, that means single PFN should be deloaded and stopped. We should operate 100 megawatts at single PFN to be in loading condition. Mill airflow has been also taken into account for again PFN only. PA header pressure suggested as minimum as 700 up to 710. This is the flue gas profile. Not much of a problem in flue gas temperatures and profile. Table में. The flattened trends shows that there was no problem. If there might be a case that we have faced any of the problem, that this would have seen as the zigzag trend, but the line were very much flattened, so there was no problem. Flatten superheated outlet temperature running minimum was 641, maximum it has gone to 663. Not much of a fluctuation there. And suggested is proposed is 640 to 665 is okay. Likewise, PSH, reactor outlet temperature also 550 to 570 flue gas temperature. This is a flue gas temperature profile. Again, when flue gas temperature is investigated, we have investigated it to APH also, inlet temperature and outlet temperature. So in this whole data sheet, we can see that there was no much of a deviation as far as the operating parameters are concerned. And the proposed one also are the very much close to the operating condition. Now we can see steam flow profile. ऊपर ही आना table और ऊपर टेबल आता है बस. For 95 to 111 megawatt condition, main steam flow profile, we can see that again in this condition we have suggested for plus minus 5 degrees, and the running data was also was close to the proposed one. So in this condition also we have not faced any problem. MTM. We have to manage some operating condition regarding MTM, because this is very much proportional to the ramp rates. If ramp rate is, we have operated it for a ramp up of 0.8% and ramp down for 0.5%. So we have not seen any parameter deviations in these conditions. But for the higher ramp rates of 2% to 3%, it might be a problem causing them. But we have not seen, but we have not addressed this problem during that operation. When feed water profile is introduced, as we have suggested unit drive operation, because we saw the fluctuation in drum level and significant fluctuations were there during low load operation or the ramp down condition below 145 megawatt. So we have suggested it for unit drive operation. That should be the safer one, I suppose, because the drum level fluctuation was significant higher. Minus 40 to plus 30 was there, and plus 30 to minus 20 was there for the upper ramp rates and lower ramp rates. So it should be a proposed data that it should be a unit drive operation. AC/DC profile. Wind box to you should look at to the point number 3. Wind box to furnace DPT. Minimum was 20, maximum was 34, and the average was 31. And this is our concern. As far as furnace to wind box DP is concerned, at lower loads, 31 mm of WC is the only parameter we have managed to achieve. And it should be somewhere around minimum around 50. And in this condition also we have operated for unit drive operation, that is 1 ID and 1 FD. Not much of a concern in mill operating parameters. 3 mill operation should be there with approximately 80 ton of coal flow, with considering the specific coal consumption, specific coal around 0.78 to 0.80 along the worst side. 0.8 से जब हम ऑपरेट किए थे तब 0.8 था उस दिन. हाँ उस दिन था, हाँ that day. नहीं 0.75 हाँ उस दिन जिस दिन हम ऑपरेट कर रहे थे 0.8 था 0.8 के लिए जीसीबी अराउंड 2800 रहा फ्लेम इंटेंसिटी इज अ प्रॉब्लम ऊपर करना थोड़ा सा ग्राफ से ही समझ में आ रहा है कि फ्लेम इंटेंसिटी थोड़ी सी डिटोरेट हुई है एवरेज कंडीशंस में आने पे ठीक है पैरामीटर उसमें आ गया पीपीटी में आ गया हाँ ये ट्रायल इंटेंशनल नहीं था ये हाँ 40 मिनट तक यूनिट ने हाँ जी सर हाँ बीएफपी दो थे इसलिए हमको ड्रम लेवल में फ्लक्चुएशन दिखे तो बीएफपी में फ्लो सर अराउंड 450 के आसपास था 450 इसलिए था सर क्योंकि उस दिन यूनिट में बीटीएल भी था वॉल्व एक ही सर्विस में आता है टर्बाइन वाइब्रेशंस वर एब्सोल्युटली नॉर्मल कोई इशू नहीं था टर्बाइन साइड में केमिस्ट्री पैरामीटर्स अनबर्न कार्बन में भी कोई चेंजेस नहीं थे 1.5% जो है हमारा अनबर्न कार्बन बॉटम एश में उससे बिलो था और सिलिका के पैरामीटर जो ड्रम की केमिस्ट्री थी वो भी फाइन थी ड्रम लेवल फ्लक्चुएशंस था क्योंकि पीआईडी कंट्रोलर का ही प्रॉब्लम था उसमें क्योंकि पीआईडी कंट्रोलर हमारे उस लोड के लिए डिजाइन ही नहीं सिलिका में कोई चेंजेस नहीं आगे बढ़े कमिंग बैक टू द प्रेजेंटेशन coming back to the presentation, I will ask Rajesh sir to continue from here. Rajesh sir.
Sandeep. It was night delivery. So he has given the brief description about the 40% achievement and 55% achievement during our opportunity shutdown. So we have faced during the flexibilization problem we have faced. So we are planning to mitigate those challenges, and these challenges can be mitigated by certain action plans. So I am going to discuss those challenges and what are the action plans from our GPL side for achievement. So what are the main topics I will discuss? These are the major challenges. What are challenges we are at present in the 40% flexibilization, and what may be the current scenario in considering whole all of the power plants. And also beside this major challenges, there are challenges in combustion. The first come the challenges in the combustion process, which can't be avoided. So combustion process, whatever the challenges, we'll discuss regarding that in the second point. Then in boiler, turbine, and the what Sandeep already described, the operation at 40% load and what are the parameters those things has already been discussed in the previous discussion. And also we have certain roadmap. Roadmap in the means to say, as present we have running at 54% technical minimum, and we have to reach to 40%. So that can't be achieved in a single day. So we have to plan for that, and there is certain roadmap for that. It is a 18 days roadmap, and accordingly I will give brief discussion. So based on the current condition, what are the major challenges for our plant and also for the other power plant to mitigate this 40-point flexibilization? That the main comes to maintain low airflow demand. As we know that we have to reach the 40-point flexibilization, then the required airflow is 35 to 40% of the designed total airflow. So it is a big challenge for our industry and our plant to maintain this low airflow demand. It will be a challenge, and also can be achieved, which can be achieved by certain steps, which I'll discuss further also. Next come the tuning of control loop to adapt it to the low load operation. On control loop in the means, I would like to say control related to the super temperature spray, control loop related to single, as already been said by Mr. Sandeep, that we can achieve 40 only by single uni drive operation. So in that case, unit drive operation requires a much more control loop tuning. And lastly, the mill auto operation, that also required much more tuning. What are the third point? Consider the chances of occurrence of low airflow tripping. As it's clear that we are running at low airflow, total airflow at 40-point flexibilization. So there may be chances of airflow tripping. So we can mitigate this also. So at present we have built few modification plan. At present we haven't any modified in our current scheme, but in future we'll add this scheme. That also I will discuss in next option. Flame stability. Flame stability, we can't avoid this challenge, because at low load, air rich mixture, airflow, and with the optimized excess airflow, there are chances of flame disturbance, which can be optimized or achieved only by adjusting the SADC, means secondary air dampers, and total excess air in the boiler. Next comes the closeness to unit tripping. As we know that we are running with if we're going to achieve this 40%, then we are running the unit with a single drive operation and low airflow. There will be chances of the unit tripping, but it may be when if the condition comes when if there is a equipment failure or any outage related to instrument fault. Otherwise, it is totally possible, because at low load operation we have seen in the 40% fluctuation operation, the opportunity operation, that it is possible, and you can manage that airflow for the unit running at 40%, mean 100 megawatt. Last come the coal quality variation. Coal quality can be avoided and one thing is that coal quality it doesn't come under our hand, because it can be vary based on the coal availability in the market. So there, but what we achieved to get in the JPL, it is around on an average 3,000 to 3,200, which can be much more sufficient enough to run the unit at this load. So combustion process means what are the challenges in combustion process? Combustion process means first of all we'll discuss about the coal quality impact. coal quality impact, that we are quite clear that in our Indian market, low VM coal is what VM means, VM 18 to 30% VM coal is already available in the market. There are certain Indian mines that provide less than 18% VM coal. If that coal is provided, then in case there is a possibility of flame instability. So that is the major concern if coal is not provided as per the requirement. So low VM coal should be tried to be avoided. Then the coal having high moisture. In rainy season, there is chances of high moisture. So in that can be managed by plant, and we are trying our best to get the moisture low moisture. But in case if we got the high moisture coal, there is tendency of flame quenching, and because it absorbs latent heat, and there is chances of high coal consumption to achieve the same load, because due to high moisture content in the coal. So these 2 points comes under the coal quality impact. Secondly, the combustion airflow. As we have already said that we are running at a 35 to 40% of the designed airflow. So it's just a marginal at that position that we are at. If certain change in the airflow may lead to the flame failure, or less than that airflow may lead to the it risk zone at the low airflow. So both sides we have to manage and get it at the optimum airflow. So to reach the optimum airflow and avoid the boiler tripping, that will be the major challenge in the combustion airflow. Next condition. What are the challenges in boiler? So first of all comes the PFN. As already Sandeep has informed that during 40% operation we have made single PFN operation. So that's the only solution to avoid the PFN stalling. Single PFN operation is the only solution, and with the single PFN, what the minimum airflow we can lead, that is the 210 TPH. That can be also a critical zone, but it is at this condition it was found the coal airflow was sufficient enough to 3 mil operation, during 3 mil operation. Next, as I have discussed the coal quality, for the coal quality there is not much in our hand. We can adjust opening of the fuel air damper and optimize airflow, that I have said already. That is the only option for coal quality variation. Secondary airflow, what we have seen in our plant, that secondary airflow are also found fluctuation. For that also the single FD operation is the only solution, and moreover the total airflow what we have proposed, that was 165 TPH, which was expected. That is so it comes very lower zone. That this is the reason behind the low windbox DP. So also the fourth point is the same windbox DP. So as we have seen, the 165 TPH is very low amount to run the unit. So this low windbox DP can be managed by SADC and maintaining all our optimizing the SADC opening and total airflow through the SADC damper.
Sir, sorry for interruption. Can I ask 2 questions?
Sir. One is to
लोकल लोग हैं ना, वो लोग वही लोग उससे देखो वो हाथ उठाने वाला एक तो
ये सर अपना अगर मैं 4 to 4.5% अगर ऑटो लेते हैं तो उस केस में है, और अगर मैं अपना O2 परसेंटेज एक्सेस ऑटो बढ़ा लेता हूँ तो मेरा मार्जिनल तो बढ़ता ही है सर। एक्सपेक्टेड है मतलब।
Excuse me, sir.
PFN 210 है सर।
Hello, sir. I am from Sasan.
5 अगर सर इसमें टोटल एक्सपेक्टेड सर 560 है। हाँ ऐसे होगा।
210 में क्या एक PFN में अच्छा करता है, इसमें 2 PFN आ जाएगा ना तो
मिलिंग सिस्टम,
Excuse me, sir.
मिलिंग सिस्टम देयर इज आल्सो चांसेस।
Sir, can I ask some
मिलिंग
questions?
सिस्टम में अनरिलायबिलिटी, there is also unreliability in the milling system that can be also achieved by provision of local operation. As we have at current scenario, we are having the cold air gate as a local operated, that can be done by providing the auto operation from DCS, and we can suggest the C&I to make pneumatic cold air gate and also the mill automation to be provided by C&I. That is the action plan for achieving this milling system unreliability. Secondary airflow measurement. Boiler we have found that secondary airflow also found fluctuation in regular basis on during the ramp up ramp down. So we have found that the transmitter impulse line are getting choked. So we have also suggested to C&I to increase the size of the impulse line, and this problem can be also sorted out. Huh? It's flue gas only, due to flue gas.
No, actually what happened during the low load operation, we have seen that the DP from where we are making the air, it somehow misleading. Sometimes it become sluggish, putting airflow in left side, right side within zero. What happens? The calculation coming out the one side is something zero. So what will happen? It will no, that is yes, the problem is that we don't have the regular cleaning of it. So now what is we have okay, we are going for the regular cleaning of it. So nowadays we are not cleaning it. Purging is there. This is analyze by opening the window, as is there, and it is carry over from the liquid. But not is that much big amount, but sufficient to soak the impulse line, because you know impulse line having the very lesser. No, it's not like it's not changing the impulse line, but pursuing the impulse line is more frequently. So that's why what is this such a looking of the impulse. Yes, we are trying and we have actually worked on the problem.
During every overall.
But you know, it is
Durgesh, am I audible?
yes. And this 78 is coming from the APD. So basket, you how much ever they are cleaning it, but
Ji sir.
Ask Sasan to ask some question. They were trying to ask some questions. Sasan, you may please ask the question.
Yes.
Is that? Ask the question. The speaker is waiting to answer the question. Can you please ask the question?
Yes, question please.
Or you can put it in the chat box.
This continuation, no question for you.
So the next point, the challenges comes is the maintaining NOx limit. So as we know that during low airflow, window box DP is lower side, so we can't very marginal opening provision of LOFA and OFA, upper fight. So we can that can be optimized, but it's a problem and it's a challenge still. The next challenge is a low flue gas exit temperature, which may lead to the acid corrosion. For that, we have suggested APH bypass damper to be kept in service. That is be according to throttle condition, so that we can achieve the desired temperature at flue gas outlet. Next is the boiler tripping on flame failure. So for that, we have planned a certain modification in the oil gun operation. We will give a auto cut-in oil gun operation and mill tripping, and during low flame intensity, we will give the direct command to the oil gun, and which can be if in case the manual intervention takes time, then it will take auto command and will start. The oil gun will be activated. So the next point is a boiler tripping on low airflow. So for that, we have suggested few modification in our current scenario. That's a cold air gate at the upper mill. We'll give a logic for upper mill cold air gate opening, so that minimum airflow total airflow loss will be attended, and the fast forward increment, FF increment, fast forward increment to the airflow controller, to the FD fan outlet blade pitch. We can provide a fast forward increment so that the total airflow or minimum airflow loss can be achieved. The next comes the boiler tripping due to single dry operation. The single dry operation is the only solution, and to save this, it's a operation and the C&I total team effort. So it can be hardly because of failure of equipment or malfunction. That can be much achieved by much accuracy from both sides. So next come the challenges in the turbine side. Turbine side, first comes the high exhaust fluid and HP exhaust steam temperature. For this, there is a only solution to maintain the parameter, means we have to manage the vacuum, condenser vacuum, design condenser vacuum, and avoid, we can't exhaust spray should be avoided, and for that also we can if required, it should be check the chemistry parameter for the DM condensate water to so that if in case exhaust spray is required, that can be not harmful to the turbine. That in the next is the director level control challenge. As you know that the at 40%, the total condensate flow requirement will be around 250 TPS. So for that, the single solution comes that the single CP operation. Single CP, in that case, single CP operation can be easily managed to achieve this requirement. Last stage, blade vibration. This is the major challenge in every power scenario, but this can be also achieved by maintaining the HP exhaust temperature, as we have seen in the 40% flexibilization case study, that we are achieving the temperature for the to avoid this last stage dryness to manage the dryness fraction. There are also chances of fluctuation in gland stream pressure. Fluctuation in gland stream pressure just because at 40% technical minimum there is it is an interface phase where self sealing and main supply may be intervened, means chances of come in the main supply and service in the service, so that can be achieved by maintaining the controller and tuning much more better tuning. At present we are not facing it, this problem in to maintain the gland stream pressure. These are the challenges. So next comes the what Mr. Sandeep has already described regarding the 40% operation load. So which was done on the 17th March, and we have got the detailed data and also discussed with the team also. So it was a fruitful result. We have seen that we can achieve this in very without any modification required. So we are proceeding for this challenges to overcome, and also to same experiment on a single unit of 250, that will be unit 1. This data has already been discussed. Skip this slide. Then comes the roadmap. What I have said, that as we have planned for 40% flexibilization, to achieve this 40% flexibilization, where at present we are running at 54% load, that is 135 megawatt, and we have to decrease and reach to 100 megawatt. For that, we have certain plan, that is from day 1 to day 18. So we'll, as we are quite comfortable to run it 54% or 52%, because already we have run the unit at this condition. So next, when it's come to 50%, to achieve the 50%, so at this condition, we are planning to stop the second fan, maybe ID, FD, PA, CP, BFP, all second fan will be stopped at this condition when we will reach the 50% load. And during the opportunity shutdown, we have seen that it was a hectic task, but it been possible, because already we have stopped one FD and one PA. So that's not the challenging for at present our JPL 250. Further, again comes at challenging part, that 48%, 46%, and decreasing to 40%. So it's all based on, as we have discussed the total challenges. The challenges are total same thing would be the major factor during operation. This total airflow, VFP running with minimum flow, and superheater spray to avoid this control loop tuning, and 3-mil operation is quite comfortable in 250. So these parameters would be keenly monitored by the operation, and parallelly the support of C&I, we can if required control tuning can be done. Further, no much modification, same condition, but we parallelly at the 2 days interval will start decreasing load and record the data, do the analysis. If any problem arises, we can stop the experiment there only, and we can discuss with the team and then move forward. And further, around 17 days, we can achieve the 40% load and give the as per CA guidelines, what are the requirements of the industry, we can achieve that 40% load. That's all for my part. Thank you. Any questions? After that, I would like to add one more thing. This last month, June 22nd, June 22nd, we have got same type opportunity and we have done the experiment on minute 3. And at this time, we have run around 50-55 minutes and we haven't faced any problem. And flame intensity was also greater than 45 and 50%.
बस आप जो भी बोल रहे हो, that is nowhere the requirement of CA guidelines of the RAM. एक बात आप ध्यान रखिए, आपका जो maximum RAM rate available है, because we have also conducted the study at your plant. So yes, Davidson was also here. We have conducted the study at your plant. What is the? You must not forget while doing that this test. What is the requirement by CA? The mother 23rd of January 2023. ये जो gadget जो निकला है, how close is you are near the gadget? That is the measurement of the first measurement. आप मैं जो वहाँ example दे रहा था, जो 50% का बता रहे हो, 52% का बता रहे हो, 40% का बता रहे हो, ये is this in line with the CA requirement? Or it is not in the CA requirement? That also you have not presented anywhere. You have only trying to tell that we have done. Your first challenge you should have been mentioned that it is not meeting the requirement of CA as per the guideline.
No, we are on the roadmap. Means we are planning to achieve, and that's if possible or not.
तो रोड मैप में पहला चैलेंज यही है
हाँ.
सीए का रिक्वायरमेंट अभी हम मीट नहीं कर रहे हैं, लेकिन आप कहीं भी इतना बड़ा स्लाइड हमने पूरा दोनों मिलकर दिखाया है, बहुत बढ़िया है. I must congratulate you that you have rightly pointed out all the challenges, whatever is best possible way to write down on a piece of paper. No doubt about it. Yes, these are the real challenges. But if you carry out, even you will be able to carry out with the help of C&I people, you will be able to carry out 3% rep also, or 2% rep also, or 1% rep also. That's not the issue. The issue is that you will find out a new set of challenges while you do so.
So, सर वही तो
सर
वही प्रॉब्लम जो हम आएगा या फिर हमको मिलेगा, तो वो भी हमारे लिए एक चैलेंज होगा, फिर उसको मिटिगेट करेंगे. अभी एट प्रेजेंट जो हमने बेस्ट पॉसिबल कंडीशन एट
नहीं, मेरा कहने का सिर्फ एक ही है, बढ़िया एक प्रेजेंटेशन है, इसमें किसी भी जगह में इट गोस टू द हायर मैनेजमेंट, दे विल थिंक अरे वो तो हम तो कर ही लिया है, हमको क्या करना है. दिस इज अ रॉन्ग सिग्नल इज बीइंग सेंड टू द मैनेजमेंट. The management should know that yes, we are in a challenging path. We have to resolve these issues. These are the issues. And what I am telling is not attaining the goal is also a challenge apart from this technical challenges. And if I try to follow up that path, more challenges will emerge out. ये बात slide में कहीं ना कहीं आना चाहिए था.
Yes, certainly, sir. This is actually some experiments carried out by Tamnar team. How far they can go with the existing systems. Of course, it is not meeting the CA requirements. That requires a lot of modifications or renovations or some new technological upgradations to meet the CA requirement completely. But to understand what are the challenges we are going to face, these experiments were carried out so that there is some clarity, and when we are framing the things in specifications and other things, those things should be clear to us. For those purposes, these experiments were carried out, and whatever the learnings were there, that were listed out. You have rightly pointed out to meet the CA requirements, government notifications, we need a lot of things to do.
Yes, this team is doing a great job. Let them continue. I must congratulate them. That's the first I told you. But the challenges, my intention is to tell that is also one of the challenge of today's scenario. That also should have been touched upon. Number one.
Yeah,
but
definitely.
AHL, I think if you can remember, Jorisab, that AHL has deputed the team to your plant and collected the data during that time. We have also submitted the report also. It is in the similar line what you are showing. That's a very good observation by your team, and certain modifications can be done in-house. Certain modifications cannot be done in-house. That is my only point of concern is on this thing. Otherwise, it's a very good presentation. All the points, all the challenges has been written down in a nice manner.
Thank you, sir.
सर क्वेश्चन यार बाद में रखिएगा सर, समर सेशन में क्वेश्चन यार रखिएगा सेशन वाइज, वो बेटर रहेगा। अगर इस क्वेश्चन का कौन जेपीएल
क्या हुआ?
क्लैरिटी आपकी प्रेजेंटेशन को खत्म कर लीजिए, उसके बाद समर अपना अपना नोट कर लीजिए। मेरा सजेशन
हाँ, complete हो गया।
एक साथ प्रेजेंटेशन खत्म करने के बाद ओनली आफ्टर दैट इंटरप्शन मत कीजिए।
Okay, thank you.
Thank you very much, sir, for your wonderful presentation. From operator's perspective, how we can able to tackle the operating regime of 40 minimum technical load, how it can be achieved, what are the challenges ahead of us, and what could be the solutions that can be made to tackle the situation, which has been explained event-wise in detail with evidences. And definitely, we congratulate all of you, especially the JPL team, for taking such an initiative in advance in achieving and experimenting these, achieving technical minimum load in an opportunist way. And your presentation comprising of detailed analysis from operator's perspective, especially with the parameters wise. What are the various parameters and what are all the changes that took place during these operating regimes, and what is impact on these various parameters and consequences that has been captured in very detailed manner with graphs, trending graphs and all that. Of course, definitely our seniors will be also working on this point. It is not only restricting with maintaining the parameters. Beyond that, what would be the impact on the performance of the various systems and equipments, and in due course of time, especially in the long run, what will be the impact of the system healthiness as well as the life of the equipment has to be analyzed. Probably SAR will be able to give more highlight on these aspects. But however, whatever the information furnished is very valuable and experimental investigation. Once again, we congratulate you for making such an attempt to capture this event. Definitely, this would have given a lot of input for and insight for the operating engineers in tackling this challenging environment. With these few words, now I would like to request, we are going for the next technical session, which will be delivered by Mr. Pulok, Mr. KVC from BHL, sir, from BHL, and we are ready to share these technological solutions from the manufacturer's point of view. Definitely, they are the gurus who has developed the systems and provided the system to us, and now they will be also ready to help us and guide us during this challenging environment. So, on behalf of you, I welcome Mr. from BHL to present this session.
Yeah, good afternoon to all. So we have been talking about flexibilization for quite a few years. And DHL has also worked on this new. It's not. Hello. Now it is better. Yeah, so we have been talking about flexible operations for last few years, and BHL has also worked on this field, and we have tried to make some studies on pilot basis, and then we have analyzed the data and come up with a roadmap that how the challenges or issues that are being observed with respect to the flexible operations. So how those are to be handled, how those are to be mitigated, and how those are to be controlled. So this is our presentation that how we are going to do on the flexibilization journey. So to begin with, mainly we will be discussing about the regulations and challenges, then role of BHEL, and finally, what are the achievements in the flexibilization journey that BHEL has achieved. So coming to the regulations part first. So if you go for the upper half of the slide, which is the mandatory requirement for all the thermal sets, which is to be achieved by 31st December 2023, that you have to achieve a 3% per minute load ramp rate between 70 to 100% TMCR. And you have to achieve 2% per minute load ramp rate between 55 to 70% TMCR. So this is a directive by CEA which has to be achieved by all thermal stations, irrespective of the rating, irrespective of the design, immediately. Because if we are talking in July 2023, then December 2023 is not very far. So all power sector utilities have to act in an immediate manner on this part. Second requirement that CEA has given is based on the phasing plan, which CEA has given as per their regulation in dated 1st May of 2023. In that, they have given the requirement of low load of 40% TMCR, and which is to be accompanied by 40 to 1% load ramp rate between the 40 to 55% load range. So this requirement is also coupled, which is a second level of requirement that CEA has given, and it has to be immediately followed by the first part. So there is a challenging task ahead for all of us working in the power sector. So we all have to gear up for this, and it is a requirement of the nation. So we have to follow this requirement. So when we are going for the flexibilization, when we are doing any analysis or studies, as JPL team has also conducted and they have shared their observations. So what are the key challenges that are being faced? And when we are listing these challenges are mainly captured in the existing state of the plant without any modifications or without any solutions that have been implemented, because the modifications or solutions will try to address or mitigate these challenges. So the major key challenges that are there is that what would be the minimum threshold load or MTL or TML that you are referring to for the sustainable operation. So when the flexible operation talks had started, people were quizzed that how much down we can go. Some said 75%, some said 60%, 55%, 40%. All numbers were flown in the discussions. But now CA has given a clear mandate that they want 55% immediately, which was already implemented by 1st of April 2020. And later on, they have given a directive for the 40% requirement also as per their January 2023 directive. So all the thermal sets are required to go to 40%. And what are the challenges they are going to face, that we will be discussing. Next is load ramp up and ramp down rate. What would be the maximum that can be achieved, and what would be the stable, and then what would be the bearable for the machine also, because we cannot compromise the machine health also. So what would be the safer number, looking at all these three aspects that we have to decide. Then what would be the excursion range of the operating parameters during the ramping requirements, and as well as when we are going for the minimum load operations. So what would be the variations in the steam temperatures? What would be the variations in the flue gas temperatures? What would be the drop in the steam temperatures? What would be the drop in the flue gas temperatures? All these are the concerning numbers that we have to look upon. Next is the response of the plant equipment, auxiliaries, and the control logics, that how they are behaving. So presently, if you are doing a ramp trial of 1%, you are not achieving 1%. You are achieving some 0.5%, 0.6%. It is depending on the state, unit to unit. What is the health of the unit? What is the fuel being fired? What is the operator's comfort in the ramping exercise, and how the unit has been being operated or is being maintained. Next is high life consumption of the components. So it is mainly with respect to the temperature deviations that are happening, temperature excursions that are happening. So certainly that is going to consume extra life of the various equipments. And next point is regarding the time required for the unit startup in various modes, because as we are saying that in some cases units would be required to go for the 2-shift operation, or even reserve shutdown. So that would be the extreme case, but certainly that would also be a prevalent scenario in future for the thermal sets. And certainly, so unit startup would be a challenging task in that condition in a faster mode. If we see on the right side of the slide, we have put a curve. So in that, we are trying to capture that what is the impact on the machine condition in the various operating modes or various operating regimes. So these machines were originally designed for base load operation, but now we are being forced to operate them at low load levels like LL1, LL2, LL3. So in the present scenario, I would associate LL1 to 75% unit operation. So 75% unit operation, many utilities were comfortable with, and they were previously also operating it. So, but still, its LL1 was also having some life consumption. Now this LL1 has been revised to LL2, which I would say in the present scenario is 55%, which is the prevalent scenario right now. And most of the utilities are coming down to 55% as per the grid requirement. And now LL3 is the 40%, which is the challenging task which CA has given to us for the future to be met. So 40% would be the requirement that we are going to target. Next is hot startup, warm startup, and cold startup. So if you see, the area under the curve is basically representing that what is the life consumption in each case. So as we are talking about the various low load levels and then various startup conditions, the area under the curve is basically increasing. So that means the life consumption of the equipment or the overall machine is getting increased. So with the flexible operation regime, we are consuming the equipment operating life. So
actually, I request JPL team that you start collecting these data very importantly. How many starts you have done, and try to study that what are the temperature you have collected during the match. You have gone up to that temperature level during those times. You have to go to the life cycle of the machine from the day 0. So it's a big task, and it is mandatorily required for the implementation of flexible operation at any of the plants. At any of the plants, I'm talking to all the vendors whoever has here requested to collect their data. Individually we will use the biodata of the machine. So try to collect this data from day 0, from the how many hot startup, how many cold startup, and how many warm startup we are already collected, and how temperature, at least 1 or 2 graphs during that startup time. So may not be able to get all those Victorian, at least 1 or 2 graphs are very important. Average and things can be. I think most of the data are available in this. MS, HRH, temperature, drum level. Water level, drum level, MS, HRH. So the more critical parameter needs to be very correct.
So now we are coming to the role of BHEL, how BHEL can.
No, we have to create the code. Yes, during the startup, because what we have in pre-startup, the creep damage and the fatigue damage. Basically, the fatigue damage depends upon these data. People are not aware of this fatigue damage, thinking that whatever you do, everything is wrong. These are the basic data to be generated at all the processes. So the day 0 birth certificate of the baby can be used while using the flexible.
During this data, sir, time duration would be required. So certainly it will mean that the rate of rise is also getting.
Around three times the peak of data per region का होने से भी average out कर दिया था कोई दिक्कत नहीं क्योंकि हम अगर बोलेंगे 1997 का डेटा निकालो और उसका देखो तो क्या था ये पॉसिबल नहीं है बट नंबर ऑफ स्टार्टअप्स की रिकॉर्डेड रहता है तो वो एक तीन वे में इसका मेंटेनेंस होता है वो जो मेंटेनेंस प्रैक्टिस होता है वो प्रेजेंट एमिशंस है ये अब तक का ऑलरेडी पॉसिबल तो लगता है ठीक है तो नहीं रखते हैं वो नहीं रखते सर ऐसा है ना जो नहीं रखते भाई आप यहाँ का बात नहीं कर रहे हो पर लेकिन सर टू एवरीबॉडी दैट इज वेरी मच
So as a OEM, BHEL has been a pioneer in thermal equipment supply. So we are the largest engineering and manufacturing company for thermal power plants in India. We have vast experience in design, engineering, construction, testing, commissioning, and servicing of thermal power plants. We are OEM for more than 400 utility sets. We have immense experience in dealing with Indian coal for boiler design and performance. And we would like to stress here that our experience is unmatched for Indian coal, and nobody can come nearby in that region. We are the only company having experience for both boiler and turbine area, which is the most affected component in the flexible operation regime. And we are having the capability to provide end-to-end solutions for all our customer requirements for performance issues and optimization. So as a flexibilization partner, what BHEL is going to offer you is that we will review the unit in all aspects. We will provide end-to-end customized solutions. We will give training and handholding support for flexible operation regime. We are having innovative, affordable cost solutions. And for flexible operation, our motto is that we have to protect the machine flexible operation requirements. And it will be coupled with improvements in the unit stabilization in all flexible operating modes.
Why the role of BHEL in the industry of this flexible operation? Let me add one of the lines. This is a very low cost affair. This modification, flexible operation, it's a very low cost affair. Probably companies like BHEL would not have been interested to come in the picture until and unless it is being directed from the top, like chairman of my organization and from CEA, that mitigate the effect of the flexible operation needs to be taken care of first, rather than carrying out the flexible operation. So the role of BHEL is to provide you the mitigate the only the providing the solution. Most of the persons are giving you the solution, no doubt about it. But how to save the machine for future, the part 2 of our game, that is the beauty of BHEL. How to save the machine for future and with the technical challenges. Number 1 and number 2, आप जो भी करेंगे investment, ultimately किसके ऊपर में जाके cost गिरेगा? देखिए, there is a compensation mechanism already has been declared by CEA. probably CERC also has calculated power station के ऊपर वो presentation मेरे पास है, तो वो already हो चुका है. I'm not talking about the cost. Who will ultimately pay the cost? Utilities के पास में पैसा तो आ जाएगा from the जहाँ लोग यूज करते हैं, है ना? तो लेकिन वो करने के लिए कुछ स्टेट ऐसा है जो करने के लिए परमिटेड ही नहीं है. मैं नाम नहीं लेना पड़ूंगा. इस स्टेट में at this moment rate division is almost possible. That means the solution must be very very cost effective. ऐसा solution देने का फायदा नहीं है. जो solution highly cost effective ना हो, point number 1. Cost effective मतलब हमको keeping in view of the number of light I have consuming. That's why I was thinking correct that. That is how much I have GDI मेरा 60 years already cross कर चुका है. तो मैंने कितना जी लिया, कितना जीने की तमन्ना है, तो मैं उतना ही तो यूज करूंगा पैसा. या पता नहीं मैं जीने की मैं अगर सोच रहा हूँ तो काफी 200 साल जीना चाहता हूँ, मतलब मिनी खर्चा करता जाऊँ. कोई भी मशीन ऐसा चलता नहीं है इंडिया में. बस अभी भी हमारे रेड्यूस का मशीन चलता है. अभी भी मशीन सिंगुलरली नंबर 1 और 2 30 इंडिया मशीन है, वो भी 100.5 पीएलएम से चलता है. तो चलता है, बट रेडियोलॉजी कभी भी हो सकता है. चलता है क्योंकि वहाँ मेंटेनेंस अच्छा हो रहा है, ठीक तरीके से देख रहे हैं, सीरियल चल रहा है. तो हाउ मच द इन्वेस्टमेंट शुड बी इज अ वेरी वेरी ट्रिकी अफेयर. और ज्यादा कॉस्ट खर्चा करके बीजे का दिखा एक लाइन मैंने दिखाया था, इनोवेटिव अफोर्डेबल कॉस्ट फंक्शन. दैट इज द मेन थिंग. अदरवाइज ये फील्ड ऐसा है आप कुछ भी कर सकते हैं, मांग सकते हैं. आप ये भी बोल सकते हैं मेरे को ऑनलाइन मदद दीजिए, मुझे सफाई मदद दीजिए, मुझे ये कर दीजिए, वो कर दीजिए. इतना करने से बहुत बढ़िया हो. कोई दिक्कत नहीं. हाउ मच यू आर पेइंग फ्रॉम योर पॉकेट, हाउ मच यू बी एडेड टू योर कैरी, दैट इज द मेन इंपॉर्टेंट थिंग. सॉरी मैं टेकिंग यू इन. सो लेट्स
For clarity की जो
for clarity मैंने सोचा जो
A few of the notable accomplishments by BHEL are that we have conducted studies in all ratings of machines which are earmarked for flexibilization, and we are also executing commercial orders for our customers. As part of flexible orders executed, we have already achieved actually 3% per minute load ramp rates, and we have also achieved 40% TMCR without oil support, with actual load ramp rates of 1% per minute.
1.2% exactly speaking, and not once, not twice, in number of time period. Not once, किसी का दिल का धड़कन बढ़ा नहीं है, कोई ऑपरेटर का हार्ट अटैक नहीं हुआ अभी तक, और कोई अभी तक हॉस्पिटलाइज नहीं हुआ. वो आराम से कहते हैं डीजे जब करते हैं ना, गाना बजता है, डीजे करता है, वो आगे पीछे. तो ये 1% रैम रेट में भी ऐसा पॉसिबल है और ऐसा इम्प्लीमेंट हो चुका है.
And while we are offering the flexible solutions to our customers, we are also taking the initiative of Make in India Drive-by Geo of India forward.
That is one of the main things, because this product, whatever has been supplied to our customers like Adani and other customers and other wherever they are executing, this is 100% Indian product. It's produced in India. That is why we have taken the corporate organization, we are taking the price benefit under the scheme of Make in India. This price benefit has been given by Government of India to all the, if the component used is more than 80%, हमारे केस में तो 95% plus है, एक आध component भी है तो बाहर से आता है, बाकी 95%. So we fall under the category of Make in India. That is also another point for us. जो मेरी जो है आप देखेंगे कहाँ से आ रही है, it is coming from outside. We get the advantage of it.
So proceeding to the next part of this presentation regarding our achievements in the flexibilization journey. So these are our achievements in the REGL Riger project that we have achieved. So the contract requirement was 3% per minute from 60% to 100% TMCR.
But we also without that slide डाल देते हैं. But ये अपना जो है ये अपना
Yeah, REG. Tiger, Amantha only. So the contract requirement was 3% per minute load ramp rate requirement for from 60% to 100% TMCR load range. And after implementation of the solutions by BHEL, they are able to achieve 3% per minute load ramp rate in the set load range. Before BHEL has implemented the solutions, their actual ramp rates was only, around 0.5 to 0.7%. During this load ramping exercise, the superheater temperature variation was earlier plus minus 20 degrees Celsius on actual basis. And for the contract, it was required to be 10 degrees Celsius standard deviation. And we are able to achieve within that. And we have got the best figures of less than 9 degrees Celsius on standard deviation basis. Similarly, for furnace pressure variation, contract requirement was for less than 20 mm water column. And we were able to deliver less than 15 mm water column variation. For drum level variations, it was required to be less than 50 mm variation as per the contract requirement. And in actual, we are able to achieve less than 30 mm variation as per standard deviation method. So with respect to the 1% per minute load ramp rates in the 45% to 60% load range, so that for that also we are able to achieve
40% रेंज में आधानी का काम नहीं खत्म हुआ है। हम लोग अभी कुछ ये शटडाउन के बाद में उसको खत्म करेंगे। देयर आर सर्टेन हार्डवेयर टू बी इंस्टॉल्ड जो अभी नहीं हो पाया था उधर शटडाउन, तो वो करने के बाद ये भी हो जाएगा। हम दूसरा प्लांट में 1% रेट हम हार्डवेयर इंप्लीमेंटेशन करके ऑलरेडी ये कर चुके हैं। इट इज नॉट एट अदानी प्लांट, एट सम अदर प्लांट।
So prior to the implementation of the solutions, you can see that what were the level of variations in the superheater, heater temperature, furnace pressure variation, and drum level variation in the middle column. So these are on the higher side, which was certainly causing the life consumption of the unit on a higher amount. So when we are able to control the excursions within the set range, we are not able to completely eliminate the life consumption, but we are able to mitigate the life consumption within the acceptable range. So that is what we are trying to do. We are that we want first the machine health should be safe. So that is why we are much emphasizing that what are the variations in the operating parameters, what are the excursions in the operating parameters that has to be seen and that has to be controlled and monitored. So these are few curves representing the same thing. So upper curve is before the implementation, how the superheater temperature variation was happening. So the black one is the superheater temperature. So you can see a lot of peaks and dips are there. Whereas in the lower graph, you can see the amplitude has decreased.
Not one day this online is being with BHEL and with our partner online almost every day. So every cycle you operate, they go on using every day is a learning process. And this is as Patrick was saying, this is not the only solution. Various solutions are provided by various operators. This is BHEL solutions and we find it more cost effective. That is only the reason we never wanted to take the only solution. Never. There are many solutions provided by many operators, many not millions, they are not millions to say that, but they are solution providers. But cost effectiveness also is a factor of concern. So this is the ongoing process, this is not the end. Whatever we are actively trying is on the end of the it continues for almost 1 year from stage where we are building this.
So this was again our RGL Riger achievement that we had shared with our various customers that we are actually able to deliver 3% load ramp rates. So this is our another project at WPDCL Sagardegi. So for WPDCL Sagardegi also, we are able to demonstrate and achieve 3% per minute load ramp rates So as per the contract requirement, 3% was to be achieved in the 70% to 100% load TMCR load range, and 2% per minute was the requirement.
फोटो खींचने का जरूरत नहीं है, वो presentation मैंने दे दिया है, तो इसीलिए you will be able to see, don't worry, आप अपने ही आपके सब कोई ऐसा कोई थोड़ी का इसमें लिख रहे हैं जो आपने किया नहीं है, इसलिए हमको डर नहीं है.
So 2% per minute load ramp rate requirement was there in the 50.
कर दिया है, और कोई चीज इसमें ऐसा लिखा हुआ नहीं है जो हमसे पॉसिबल नहीं है या हमने किया नहीं है, इसलिए हमें कोई देने में कोई डर नहीं है. Yes, there are separate presentation on my side also. I will not present it, but that has a technical issue. That cannot be shared. This is a general presentation that cannot be shared can be talked in public, but cannot be shared officially because that has certain engineering है उसके अंदर. तो वो मैं आपको वो नहीं करता. चलिए.
So 2% per minute load ramp rate requirement is there in the 55% to 70% load range, and 1% per minute load ramp rate requirement is there in the 45 to 55% TMCR. So this is exactly as per the CA regulation that has been given. And so after the implementation of the solutions, we are able to achieve all the three requirements. The only thing is the fine tuning works for 1% per minute load ramp rate requirement is still in progress. So before the yes sir,
What is the unit capacity?
500 megawatts.
We have implemented 1,600, 1,500, and 1,250 at the back end. So data हमने दिया है at the back end, maybe another 7-8 days required. So all the images are more or less each machines, top of the supercritical capacity. All the machines of all the subcritical machines have been forwarded to the.
So before the implementation of the flexibilization solution, that particular unit was only able to achieve 1.5 to 1.7% load ramp rate when 3% command was being given. And at that time, the actual steam temperature variation was in the range of plus minus 25 degrees Celsius. Furnace pressure variation plus minus 20 mm water column on actual, and drum level variation of plus minus 75 mm on actual. So as per the contract requirement, these was required to be contained, superheater temperature, superheater and reheater temperature variation was to be contained in 12 degrees Celsius in the standard deviation. So we are able to achieve that. Furnace pressure variation was required to be limited to less than 20 mm water column in the standard deviation. So that also we have achieved, and we have improvised it to less than 15 mm water column subsequently. And for drum level variation, it was required to be less than 60 mm. So we are able to achieve that also. And further, we have tuned and improvised it to less than 30 mm. This is a typical curve for the load ramp. So for both 3% up and down. So the black line is the actual load that has varied at 3% command. This is Sagar Digi. So this is the superheater temperature variation. So upper curve is before implementation, and the lower curve is after implementation. So the green one, the dark green and light green is the superheater temperature curve. So you can see again some variation is there, though, and it has been minimized in the lower curve. So apart from superheater temperature, we have plotted one more parameter, MS pressure variation in the low load condition when 1% load ramp command was given. So it was around 245 to 225 load range. This 1% load ramp command was given. So at that time, 1% command has also been achieved, and the superheater temperature variation and MS pressure variation has been controlled within the required range. So that is all from our side. Thank you.
Actually, we wanted to make the presentation and discussion more. That is the main aim of our smaller presentation. You could have given, I would have presented a long presentation on the technical part. But I thought that first to understand, we have understood the pain from one project. The pain from others also need to be earned and to be addressed accordingly. The solution is not only one solution. Solution is a combination of many factors that need to be addressed. That's why our presentation is very small, but we want to discuss the matter largely.
So any questions from the audience?
In India, at this moment, whoever is claiming I am achieving 55%, they are not getting the right part, right? They are not achieving. No company in India is achieving 55% with the RAM rate. No company. So it is not possible. Without RAM rate, only SBA has come out that 12% of 12% of the machine, 512 machines data they have submitted. Out of approximately 60 machines have achieved their 55% RAM, 55% growth with 0.7 to 0.8% RAM. If they cross these RAM rate, their temperature expression is so high, they will not be able to achieve that. So theoretically or practically, the data submitted by CEA not being followed. So now CEA is asking that you have to follow the guidelines of this guidelines in January 2023. So that is the reason why we are again and again telling people in the concept of manage person tax career, manage it is not a fact. हमने 1% tax career, we कितना दिन marathon दौड़ और जो हम 100 मीटर रेस में दौड़ना वो अलग अलग है. अभी 100 मीटर दौड़ने के लिए किसी ने उतरा और अगर वो मैराथन स्पीड में अगर वो 100 मीटर दौड़ के पहुंचा तो इजी रनिंग है मैराथन और इजी रनिंग है 100 मीटर. We have decided that easy attending the goal. Probably the goal is not being added, but yes, congratulations to them also. We have touched their 55%. Some of the population have not even touched below the control zone of this. Our machines, parameters, are good characteristic of this. They follow up to a level of around 70%. Our normal temperature level doesn't change. Below 70%, our EQD changes. So, ये इक्विटी चेंजेस does not mean मरेगा इसका मतलब यह है उसके चेंजेस कितना हो रहा है, फ्लक्चुएशन कितना हो रहा है, ट्रिप डैमेज कितना हो रहा है, दैट इज मोर इंपॉर्टेंट रादर देन फटीग डैमेज. फटीग डैमेज तो होगा ही ना, मेरा कोई क्षमता में नहीं है, मैं उसका इक्विटी को कोई ऐसा इक्विपमेंट मैं इंस्टॉल नहीं कर सकता. इसके वजह से जो उसका इक्विटी प्रेडिक्टेड पैरामीटर है वो प्रेडिक्टेड पैरामीटर मैं अभी कर सकता. इट इज नॉट पॉसिबल, इट इज नॉट पॉसिबल. आपका प्रेडिक्टेड पैरामीटर तो अचीव करना है, बट और कंट्रोलिंग ट्रिप डैमेज के वजह से आते हैं. दैट इज द फ्लक्चुएशन ऑफ दैट नीड्स टू बी करेक्टेड. दैट इज द मेन एम ऑफ आवर who gives it, who is the what is the most affected components to which happens on this in this case. If you see the direction technology, our drum thickness is almost how much thickness? Anybody? 1/6 up to 160 mm, approximately up to 160 mm drum thickness, and header thickness and the other thickness comes from the 20 mm onward. So 20 to 160 mm thickness जब हम welding करते हैं during the welding process, तो क्या करने के लिए बोला जाता है? प्री ट्रीटमेंट एंड पोस्ट ट्रीटमेंट. क्यों बोलते हैं हम ऐसे? क्योंकि अदरवाइज टेस्ट डिलीवरी उसका हो नहीं पाए. अभी अगर मेरा ये जो डिजाइन टेम्परेचर डिस्कशन रेंज है इन मशीनों का, इस मटेरियल अगर 15 डिग्री से अगर ऊपर में आ रहे हैं, दैट इज यू आर हीलिंग द लाइफ ऑफ द मशीन. अगर 15 डिग्री इज द मैक्सिमम अफोर्डेबल टेम्परेचर व्हाट द मशीन कैन withstand. So every time I do the flexible operation, when the temperature discussion goes beyond 15 degree and above, I am killing some of the time, some of the things from the machine control. इसीलिए कोई भी कंपोनेंट इसका थिकनेस हमारा 30 mm से ऊपर में है. 30 mm to 161 mm का थिकनेस का जो भी कंपोनेंट है, इसको साल्ट कहाँ से आ रहा है? टेम्परेचर and pressure variation. Pressure and temperature combination is the deadly composition. So what is our main programming? First, हम इसको बचाने के लिए क्या कोशिश करेंगे? The temperature और pressure का fluctuation नहीं कराएंगे. दैट इज पहला सबक मशीन को बचाने का. हम कोई भी टेम्परेचर ड्रम रेट ऐसी हो चाहे ना हो, टेम्परेचर और प्रेशर कॉम्बिनेशन और ड्रम लेवल का बोलिए चाहे हम एयर लेवल का बोलिए, हम ये फ्लक्चुएशन हम नहीं होने देंगे। और दूसरा जो हम होने नहीं देंगे, हम I may compromise on the land, but I will not compromise on safety of the machine of these two things, two parameters. With these, टरबाइन में तो दो ही कंपोनेंट है जो मोटा थिकनेस का आता है, दैट इज कौन सा कंपोनेंट, एक रोटर और एक केसिंग। और कुछ केस में केसिंग वाल्व, कुछ केस में केसिंग का जो हमारा जो कंट्रोल वाल्व है केसिंग वाल्व से, कुछ केस में वाल्व बॉडी भी उसमें इंक्लूड। तो मैं अगर टेम्परेचर को कंट्रोल में कर दिया तो एटलीस्ट सम ऑफ द रूट कॉजेज आई विल बी एबल टू एड्रेस, जो नहीं, लेकिन जो जनरेट कर रहे हैं वो तो करने में रह जाएगा, जनरेट करने में तो हम रुक नहीं सकते हैं ना। तो उसको डाउनस्ट्रीम में जो टरबाइन में जब जा रहे हैं वहां तो मैं कंट्रोल कर लेता हूं। तो बॉयलर कंपोनेंट्स को बचाने के लिए पूरी भी एबल बेस्ट पर्सन टू अंडरस्टैंड दिस फ्लेक्सिबल बिजनेस, द boiler component is being affected first rather than the turbine component. Please remember that. So the boiler parameter observation of the boiler parameter, not the turbine inlet parameter, are more important for keeping the safety of the machine in mind. Right? Anything you want to ask, you can ask. I will take this forum of the KVC, has a nice presentation he has done. But the more in discussion mode we want to go, more clarification mode, so we will also able to learn. हमारा तो जैसे यहाँ हम लोगों से बात करने का more I generate knowledge about you, more my machine is the same way. That is the main reason. So also pretty much advocate by working the limited land, working the exceptional land that is in the last time I used to target mark इसलिए करूँगा. There are two ways of solving the this is called primary frequency. That should not be part of the ramp rate at all. It is the additional requirement over the ramp rate. Even whatever we have achieved in Adani Power, it is beyond that. We have not considered that thing, sir. If I consider that in the ramp rate that we are 3.69 and also data is there, we are at 2.69 also. But we are not talking about that. 2.95 to 3% is the only maximum. Till now, the process are going on because download one लग जाएगा, तो final tuning उसको हम काम खत्म करेंगे. But अभी तक तो क्या है 3% contractual जो था वो हमने सब believe me, BHEL और I am thankful to the Adani Power management. I am very thankful to them. They had given us the opportunity. हम तो पहले खुद भी सवाल नहीं कर सकते थे ये होगा. मैं इस प्रोजेक्ट में ये फ्लेक्सिबल ऑपरेशन प्रोजेक्ट में फ्रॉम द ऑलमोस्ट ये तो मेरे पहले से ही उसके इन्वॉल्वमेंट करता है और सीए के साथ में शुरू से इन्वॉल्वमेंट है वो मैंने रखा था. मैं खुद भी नहीं बिलीव करता था, मैं बट धीरे काम करते करते आज ये स्टेज में पहुंचा है. दिस इज नॉट द एंड ऑफ द जर्नी. दिस विल मूव फर्दर मॉडिफिकेशन, फर्दर चेंजेस, दिस विल आल्सो हैपन. बट कंडेंसेट फंडिंग का जो दो प्रोसेस है जिससे मैंने थोड़ा सा, one is the HP heater control, another is the LP heater, right? तो HP heater control में अगर हम करेंगे उसमें सबसे पहले अफेक्टेड कंपोनेंट कौन आएगा, उसका कंट्रोल वाल्व. क्योंकि HP heater control वाल्व में अगर हम करेंगे तो टोटल लॉसेस इतना ज्यादा होगा, लॉसेस इतना ज्यादा होगा, आपका फायदे के बनने में नुकसान ही ज्यादा. तो कोई अगर ये फंडामेंटल्स में अगर आते हैं तो HP कंट्रोल करेंगे प्रॉब्लम, so that is technically it is a loss, economically it is a financial loss for the operator. Coming back to the LP heater, LP heater called also केवी वाला जो कार है, कमिटी वाला कार है, इस वाले को मैंने भेजा था. अच्छा, तो उसमें yearly 5 to 6% gain for the 3 minutes operation is possible, and we have also achieved that. We have demonstrated. Some of my competitors has asked even 6 to 7 crore rupees for this operation from some of my users. we are doing it free of cost. We have not charged single पैसा for the हम यहाँ भी किया है, वहाँ जो भी हम कर रहे हैं बाकी सब जगह में कहीं जगह से हम पैसे का बात नहीं करें. That is one of the techniques. समझे टूल एक तलवार आपके हाथ में दे दिया, इस्तेमाल करना है कि नहीं करना है. युद्ध के टाइम में अगर आपको जरूरत पड़ेगा, आप प्लीज इसे इस्तेमाल कीजिए. इससे भी टेम्परेचर एक्सट्रैक्शन ही बढ़ेगा, क्योंकि टेम्परेचर एक्सट्रैक्शन को जो फिलहाल जो कंडीशन है कौन बजाता है टेम्परेचर एक्सट्रैक्शन को? डीसीएस बजाता है. डीसीएस का जो वर्किंग फिलोसफी है, इट्स अ रिस्पांसिव methodology. DCS is never anticipates the problem and acts. So that is the reason why the new control system is required to be installed. So fuzzy logic based control system which will anticipate the problem in advance, make the system ready in advance. So the time cycle required for the readiness is very small. That's how the RAM rate is being. That is the reason why this difference between the DCS, existing DCS. The question would have been from the C&I part, can we achieve with the present DCS? Answer is no, you cannot. You can achieve up to a limit, 1.2% the maximum on BHEL machines and non-BHEL machines. BHEL is the only team who has studied 14 number of around 10 places on this, including non-BHEL machines. On the non-BHEL machines, we have seen that the operator, not the operator, the OEM has locked their feed flow at 1% level because that thickness component is not permitting to go RAM rate beyond 1% level. HL has proposed to that we are working with Adani Power for non-BHL machine and order is in the final stage. Very soon we will get the first non-BHL order and we will implement it. There we come to know that how this thickness factor is being locked by our different OEM. Even the reputed OEMs we have started, we have seen they are been locked. They are not allowed people to go beyond the 1% level. So there are technically हम अगर कितना भी गला फाड़ने के लिए बोलने के लिए बैठे रहे हम ये करने की वो करके अल्टीमेटली किसी डिजाइनर के ऊपर में डिपेंड वो रहेगा वो हम अचीव कर पाएंगे कि नहीं अचीव कर पाएंगे. For the BHEL machine, we know that we have not done such kind of journaling during our design stages. So BHEL machine 100% guarantee. For the non-BHEL machine, with the risk factor, we are taking certain chances. But I am grateful to Nanda sir, Sadhana sir, Bhattuji, Mitra, definitely शुक्रगुजार रहूंगा. They have given us the opportunity to again work on the non-BHEL machine. So this will come very soon, and then we will come back on the non-BHEL machine also with this solution. But be careful that the non-BHEL machines are these thickness factors are different than the BHEL. BHEL का machine बड़ा होता है, हमें कोई problem नहीं. And one more point that I want to touch in this discussion forum is that we have never talked about the supercritical machine. We have never talked about supercritical machine. Rules are not set. What it has been depicted here, it is not the rules are set. We have discussed with CEA. There is a point called Benson point. You must be knowing that the Benson point is fundamental. Supercritical machine starts in a wet mode and goes to the dry mode at a particular pressure and temperature combination. That pressure and temperature combination percentage of low ultimately. This percentage of low is called the Benson point. That Benson point normally for the BHEL machine comes around 42 to 44%. Normally, design is 40%, but depending upon the mechanical sluggishness of the various systems, it may go up to 44%. We have talked to CA that we should not try near to the Benson point, whatever will be the condition, otherwise the BRP and other parameter, other components will get affected. So we have agreed that Benson point plus minus 5% will be these things. That's why we are talking with on supercritical machine. We are going to get one order where we have clarity, right? I think OPGC persons are here also. Somebody from OPGC also. So OPGC also they have taken our they are in contact with BHEL, where we have only guaranteed up to 50% because they are the Benson point is 44%. So 44 plus 5, 49%, 1% margin, 50% is the maximum possible. Do not even dare to try below the Benson point, otherwise you will lose the life of the machine. That CA has agreed timely. So they are the fundamentals of subcritical machines and the supercritical machines will be different. That is one point I wanted to share with the forum. And anything from your side? बिल्कुल टेक्निकल सर ये एक आधा घंटे का रैंप में ये तो बने 15 मिनट का जो आपका जो शेड्यूल देते हैं उसमें तो इससे ज्यादा रैंप करना संभव ही नहीं, मशीन बन जाएगा। संभव है। आप अगर देखेंगे जो हमारे कुछ लोगों का मन में थोड़ा वहम है, तो हम तो बीएजीए का कॉन्ट्रैक्चुअल वे या बाकी किसी के साथ में कॉन्ट्रैक्चुअली वो था, किसी जगह में छोटा सा लिखा हुआ था, पर आप उस कॉन्ट्रैक्ट को पढ़ेंगे ना, किसी जगह में अचीवमेंट ऑफ द लोड की बात लिखा हुआ नहीं। रैंप के बाद तो वो हमको तो लोड अचीव करना है, हमें एक्चुअली 3% मतलब फॉर 600 मेगावाट मशीन 18 मेगावाट पर यूनिट का लोड आउटपुट में मैच करना है। नॉट दैट हमने सीएनआई इनपुट में सेम कमांड दे दिया और देखते रह जाएंगे उसका स्लैगिंग कितना है, ये तो नहीं चलेगा। हम तो इसको नहीं कर सकते हैं। तो इसीलिए जो ओरिजिनल मशीन में ये सब हमारा नहीं था, एम्बिशियस नहीं था, तो हम भी नहीं सोचे थे ठीक है नहीं चलेगा। आज का मशीन में जब से आईसी 35 रेगुलेशन चेंज हुआ है, वी आर फोर्स्ड टू डू दैट। Such a contract we are taking and we are forced to change the material, we are forced to change this Singareni contract also, the same thing we are doing. So this ramp rate, whatever we are talking at this moment, is the actual load graph. It is not the C&I input हमने कितना दे दिया। आपका कहना है सीए के पास में कुछ ऑपरेटर कुछ यूटिलिटीज ने जगलरी किया है, उसने C&I इनपुट का कार्ड उड़ा के भेज दिया, तो हम लोगों ने तो बुलाया गया है, तो भाई ये कैसे हो रहा है। भैया ये जगलरी तो नहीं चलेगा। आप कुछ भी तरफ से कान पकड़ सकते हो, कान आपके है और हाथ भी आपका है, तो पकड़ने का तरीका भी आपको होना चाहिए, आप किस तरीके से मैनेज करें। बट एक्चुअली जो रिक्वायरमेंट है, दैट इज द लोड आउटपुट इज रिक्वायर्ड, नॉट द सीएनआई इनपुट। सीएनआई इनपुट 5% हमारा पैनल में आराम से डीसीएस में पकड़ with the तीन आ रहा है, ठीक है, कभी नहीं हो सकता है। 15 मिनट में वो कभी भी ऊपर का लोड में 3% से ज्यादा वो दे ही नहीं सकता। अगर बोले जो 1% दे दो तो आप आराम से कर लेंगे, अगर नीचे 40% में 3% बोलेगा कुछ भी नहीं है, तो वो एक झटके में मेरा 40 से 100% लोड का नहीं है। बिल्कुल नहीं, वो सर वो तीनों स्टेप में they will give you the demand CRC after all this implementation, they will give you the demand in three steps. They cannot generate the demand bypassing this gadget. ऐसा नहीं कर सकते कि 40 से 100% का एक साथ नहीं कर सकते। That is not the idea. उसके ऊपर continuous schedule where the ramp rate is more than 1% or a load basis 14%. ये पॉइंट क्यों आया? ये पॉइंट इसलिए आया है, हम लोगों का जो डिजाइन वैल्यू है, मैंने आपको बताया था, जो डिजाइन पैरामीटर्स है वो मैक्सिमम हम इंस्टॉल कर सकते हैं 15 डिग्री, 15 डिग्री का झटका हम सहन कर सकते हैं, ठीक है। बट theoretically we had a presentation with CEA where we have proved if I give a 3% ramp rate at a 40% load level, the temperature expression will be to the tune of 35. So they have to agree at certain point of time, otherwise 35 degree वो machine तो बचेगा नहीं। That's why this 1% ramp rate concept in the market. Initially, CA had proposed only one ramp rate, that is 3%. It is the BAETL and CA executives who jointly sat together, decide the design rate. Total design fitness was discussed along with our boiler expert VK। ये था हमारा दिमाग था, हम लोग पूरा डिस्कशन करने के बाद ये 1% का ये बहुत मुश्किल से 1% अचीव कर पाया, बहुत मुश्किल से अचीव कर पाया। ये तो मानने के लिए कोई तैयार ही नहीं था, हम क्यों नहीं 40% से ऊपर तक इनका जो है हम कर पाएंगे। बट ये सीए चेयरमैन का सपोर्ट था, सीए का और कुछ इंजीनियर है जो सपोर्ट कर रहे थे, तभी ये चेंज हो पाया है स्टेप। इसी दैट इज द रीजन। ये 15 मिनट में आप नहीं आ सकते। ठीक yes, ACRC will see this stability zone. He will give you the, you are not having one machine, you are having two machines. He will give you the opportunity to stabilize one machine first and to go on the ramp the other machine. इनके पास 8 मशीन है, 8 मशीन ये प्रॉब्लम आएगा रायगढ़ में, इसके पास एक मशीन, मतलब अलग ही रायगढ़ में ये दिक्कत है। बट इन मशीनों में ये स्टेबिलिटी जोन वापस करने के लिए जगह नहीं है, सिंगल यूनिट है, उसको तो ये दिक्कत आएगा। बट एसीआरसी विल टेक केयर ऑफ दैट। सीए से गाइडलाइन जो ये कॉम्पेंसेशन गाइडलाइन इन्होंने इशू किया है, सीए ऑलरेडी हैज इशूड द कॉम्पेंसेशन गाइडलाइन, उस गाइडलाइन के सामने इसका भी बात जिक्र किया हुआ है, तो नहीं करेगा। अगर वो भी नहीं करेंगे, अगर आपने ऊपर किसी कुछ भी करेगा तो मैं हर एक आदमी अगर राजा बन जाए तो सर तो प्रजा तो मरना ही है, उसमें तो राजा का और कुछ हो नहीं सकता, करवा तो उसी के हाथ में, राजा के हाथ में है, प्रजा तो मरना ही मरेगी। बट ऐसा करेगा नहीं। CA is very very cooperative. They also understand the technical difficulty. They are very very cooperative. हम उसके हिसाब से ही हम आगे बढ़ रहे हैं। टाइम के बाद में हमारे साथ में और मीटिंग हुआ है, तो प्रोग्रामिंग के बारे में और मीटिंग और फाइनलाइजेशन का तोड़ हम हमेशा हर महीने में एक बार का डिस्कशन करते रहते हैं, फीडबैक देते रहते हैं। देखो हमारा बीएचए का केस क्या स्ट्रेंथ है ना सर, हम आपको बता दें ये भी दिखा रहा था। बीएचए हियर इज नॉट फॉर द बिजनेस, 5 करोड़ का 6 करोड़ का बिजनेस में आपकी फर्क है। बाकी जो कुछ लोग ऐसे हैं जिसको यहाँ से बिजनेस चाहिए वो सस्टेन इन इंडिया। We are not here to be sustained in India. We have already sustained. Yes, business हमको भी चाहिए, ऐसा नहीं है मैं फ्री ऑफ कॉस्ट में काम कर रहा हूँ, ये सबको भी चाहिए। बट हमारा मेन मोटो एज पर आवर चेयरमैन, save your machine. So I am here to save the machine. If you can do it by your own, please do it. Please do it. We will be very happy to tell you that this is the way. But practically speaking, it is not possible to do this. Until and unless we do certain. The gradation solution is varied from OEM to OEM. The gradation of work will vary from OEM to OEM. But who understands the boiler will have a better control over the. This is what I feel. So, why is the thing is now or calculation? What was it here? That's the part. Anybody any question? Mostly boiler की बात टरबाइन तो बात इनका है 4 कंपोनेंट्स है, पर बोला सर 4 कंपोनेंट्स टरबाइन होगा, AC, valve and plate. There are 4 major components which may get affected, but if I control उसका गला अगर बच्चा का हो रहा है उसको प्रॉपर हम खाना देते हैं तो ये हम एक्सपेक्ट कर सकते हैं तो उसका रुकना थोड़ा सा कम, 100% कम होगा नहीं कम होगा, बट कुछ एक्सपेक्ट कर सकते हैं सर, उसको हम कंट्रोल कर सकते हैं। बट जिससे कंट्रोल नहीं कर सकते वो है बॉयलर, क्योंकि वहां से जनरेट हो रहा है, उसका कंट्रोल करने के लिए मेरे को और एंटिसिपेट करना पड़ेगा, और वो एंटिसिपेशन इज द पार्टिकुलर अनदर कंट्रोल सिस्टम, वो ही कंट्रोल कर सकते हैं। एग्जिस्टिंग में हम टरबाइन को थोड़ा बहुत कर सकते हैं, हमारे पास हम यहाँ कभी भी सॉल्यूशन का बात हमने किया नहीं है, तो what kind of solution? See that one solution is to have the control system का control करना है, and second is the health system को monitor करना है। Health system monitoring has 2 parts. One is the boiler part, which we call as mandatory for everyone who is operating at a 40%, mandatory for everyone. The second part is the turbine part, which we have offering as an optional item, because turbine components are also exposed to the damage, but it is not that much as much of boiler component. Boiler components are more predictable to that. So इसका भी हेल्थ के ऊपर भी ध्यान देना है, क्योंकि हमको अगर ज्यादा नहीं जीना है, ये ऑल डिपेंड्स हम कितना मैं टाइम कंज्यूम कर चुका हूँ, कितना मैं जीना चाहता हूँ, और कितना मेरे जेब में पैसा है। मेरा जेब में पैसा है नहीं, मैं सिर्फ सोच रहा हूँ मैं 200 का जीऊंगा, तो ये नहीं हो सकता है। तो इसके ये बैलेंस ऑफ ऑल दिस थ्री विल गिव यू एन ऑप्टिमाइज्ड सॉल्यूशन. इट इज नॉट ए वन टाइम सॉल्यूशन फॉर द वन. What solution is provided to other may not be suitable for the other. I am executing a project. Let me give you one. I cannot name the customer. I am operating a contract with a customer where customer has said, I have some amount, X amount of money in my pocket. Very clearly, I have X amount of money in my pocket. I am ready to spend this amount of money. You find out, finalize your how much RAM you can offer me, how much temperature you can expression you can give me. Those parameters are compromisable. But I have this amount of money. So we have designed the situation to the best possibility. तो उतना पैसे में मेरा पैसा कमाने का इच्छा इसमें हमारा नहीं है. इसी तरह उसका विषय इसका क्लियर कट बता दिया. हमने भी जॉब उतना ही किया है जितना बाकी जगह में हम. ठीक है, उसके पास पैसा नहीं है. But it is a reality. It is a reality in India. How many utilities? आज अगर मैं बोल दूं मैं सबको फ्री में कर दूं, सारे utilities गवर्नमेंट देता है. लेकिन बिना पैसे का शिक्षा जो है कभी शिक्षा पूरा नहीं होता है. उसको ₹1 सही देना पड़ता है तभी शिक्षा को ऊपर में गुरु के ऊपर में आप दे सकते हैं. सेम थिंग फॉर बीएचएल. बिना पैसे का अगर बीएचएल का क्या कर दीजिए वो शिक्षा कभी पूरा नहीं हो सकता. That is the reason why BHL is a different person, different perspective than others. And we people are rolling the things. Definitely, my chairman, director, they are helping me to follow this policy. So in the market, volume से देखेंगे क्या होता है, क्या करना है. 10 लाख का फायदा करते हैं, 20 लाख का फायदा करते हैं. मशीन को बच जाए तो आप भी आपको बुला के बोलेंगे दादा ये काम कर लो, बॉयलर का काम ये दे दो, ये भी दे दो.
few hours of say 40% load अगर machine चल रही है, naturally spin parameters will be coming down and accordingly turbine temperatures etc. will come down. Now when we go for ramp up, it can reduce temperature.
Yes, sir.
When the turbine temperature parameters are low, or say 40% low, and then say grid controller is given the ramp and given that you achieve full load now, maybe say 1 hour time, meeting the temperate conditions requirements.
% point है. 70% point है. 55% point है. और ये मेरा 40% point है. ये 1% जोन है, ये 2% जोन है, ये 3% जोन है. और so these are the 4 operating points of our at this moment. पहले जमाने में हमारा क्या होता था, पहले हम जब मशीन डिजाइन करते थे तो 100% लोड almost similar parameter was maintained up to 70%. This is called controlled load. और उसके बाद में इसका ड्रूपिंग होता था. आप ये जो है 55% हमारा कॉन्सेप्ट नहीं था, 60% था, और 40% तो कभी अलाउड नहीं है. आप अगर 40% का बात कर रहे हैं, 40% का जो कॉन्ट्रैक्ट का बात कर रहे थे, जो हम देखेंगे कॉन्ट्रैक्ट में, वो 40% इस पर डेमोन्स्ट्रेशन करता है. तो इनकी पीजी टेस्ट में ये नहीं होता है जो हम 40% जो है पर्टिकुलरली ऑपरेट करें, क्योंकि उस समय में इसमें हेल्थ का क्या कंडीशन रहेगा ये कॉन्ट्रैक्ट में कहीं नहीं है, लेकिन अभी हमें कॉन्ट्रैक्ट में ये देना पड़ रहा है 40% का हेल्थ में क्या कंडीशन है। नाउ आपका सवाल जो है देयर आर टू थिंग्स, वन इज द grouping characteristics of the parameter. This is grouping characteristics of the parameter, and another is the exceptional characteristics of the parameter. Exceptional characteristics of the parameter. Now, this at this moment we are taking care of these grouping characteristics with new HBDs. आपका प्रेशर एंड टेम्परेचर ऑपरेटिंग जो है इसमें आप ऑपरेट करेंगे, ये गाइडलाइन नया तरीके से आएगा। जो गाइडलाइन पहले दिया गया था वो गाइडलाइन नहीं होगा। अब इसका पैरामीटर और इसका पैरामीटर सेट सेम नहीं हो सकता है, क्योंकि हम अभी डायरेक्टली ऑपरेट कर रहे हैं। जैसे हम 90% मोड में चले जाएंगे, सो अवर का जो ना 90% मोड मेरा प्रेशर वेरिएशन का रूटिंग कैरेक्टरिस्टिक्स हम टेक केयर कर लेंगे। बट व्हाट अबाउट this one, this should not happen, this is not allowed, this is partially allowed, and this is never allowed. So we are more concerned at this moment on the grouping characteristics of the machine rather than how it is going. Definitely our new system will take care of the new HBD, has to follow the new HBD, is the predicted parameter, temperature and parameter at the lower. But we have to be more concerned about this fluctuations more serious manner rather than this. I think I will be able to answer your question. Any question? कुछ भी पूछो ना यार, क्या फर्क पड़ता है, मन के सवाल आए तो पूछ लेना चाहिए, कोई दिक्कत नहीं है। हाँ, अरे सब लोग कौन गवर्नमेंट और डिफाइन करते हैं आप लोग का आपके प्यारे से ये किस तरह ये बेसिकली आपका जो है ना टेम्परेचर पॉइंट ऑफ व्यू टेम्परेचर बेसिकली मीटर टेम्परेचर कहां तक एक्सपेक्टेड है उसके ऊपर डिपेंड है। मैं सही बोल रहा हूं, ये इससे एक बार ये है मैं नहीं बोलूंगा, बट मेरे को समझ पता है दैट मीटर टेम्परेचर कहां तक दिखता है उसके ऊपर डिपेंड है। बेसिकली इट शुड हैव बीन नॉट द आवर, इट शुड हैव बीन बेस्ड ऑन द मीटर टेम्परेचर डायरेक्टली जो एवरेज मीटर से बात करते हैं ना, इसलिए प्रोजेक्ट समझो आर्ट से बढ़कर इंसुलेशन डेटा करवा दिया ना, उसको करना होता ही नहीं है। आजकल क्या हो गया, जो इंसुलेशन पहले कहां इतना मोटा इंसुलेशन लगा देते, अब इतना इंसुलेशन आ गया, अब ठंडा होगा ही नहीं, इसलिए वाटर से 48 कर दिया है। ये जो कस्टमर ऐसे बोलता रह जाएगा ठंडी रह जाएगा, उसको तो आ ही नहीं है। इंसुलेशन क्वालिटी हैज चेंज ओवर टाइम मच, दैट इज द रीजन व्हाई दिस मॉडिफाइड ओनली इसका यूज आपका दवाई में मैं आपका और स्टाफ को वार्म स्टार्ट में और वार्म स्टार्ट को बदलने में हमको ज्यादा दिन नहीं लगता। वार्म स्टार्ट में डेफिनेटली लाइफ कंजम्पशन कम होगा, उसका ज्यादा कोल्ड स्टार्ट में उसका थोड़ा सा स्मोकिंग ज्यादा करना पड़ता है उसके ऊपर, ठीक है। तो इसके साथ में तो हम कौन सा स्टार्ट कितना देर के लिए करेंगे ऑपरेटर के ऊपर छोड़ देने में आता है। आप अपने हिसाब से डिसाइड कीजिए कि कौन सा प्लान आप कितना देखेंगे करेंगे और वो उसी हिसाब से आप, बट रिकॉर्डिंग ऑफ दोस नंबर ऑफ स्टार्स एंड स्टॉप्स व्हिच आर जस्ट is extremely important, because what we do we for the boiler area and the turbine area, we on the newer system we provide certain around 45 to 50 sensor, additional sensor, जो सेंसर आज के डेट में आपके पास यही है। ये नया सेंसर हम लगाते हैं, this gives a signal to the, this gives a signal, new signal to the new system. So अभी जो देखेंगे मैक्सिमम बॉयलर ड्रम के आसपास में 6 थर्मोकपल लगा हुआ है, only 6 थर्मोकपल, is that sufficient to access the space? Answer is no. So all the data, all the weaknesses, all the weaknesses and all these additional sensor here that comes needs to be placed and that has to give a signal to someone. But ये जो बच्चा है एक नया जन्म लिया था आज से 90 मान लीजिए 2000 या 2000 में मशीन जन्म लिया है, इसके बाद से आज तक 2023 तक ये कैसे किया है, how it has lived, this is the will create the birth certificate of today. I need because ये birth certificate मेरा है ही नहीं, आज का birth certificate create करने के लिए करना है, ये birth certificate मेरा create हो गया, तो how much light it has consumed. And with this new signal, I will calculate every day how much light I have consumed. That's why I'm telling giving a programming or protein for your headache will only reduce the headache. But whether the headache will stay for a longer duration or not, और कैसे उसको मॉनिटर करना है और कुछ पैरामीटर देखना है कि नहीं है, मैं शायद ज्ञानी व्यक्तियों से थोड़ा सा डिफर करूंगा. तो इसीलिए क्योंकि ये कंटिन्यूअस मॉनिटरिंग होना पार्टिकुलरली फ्रॉम द बॉयलर इन एक्सट्रीमली इंपॉर्टेंट है, एक्सट्रीमली इंपॉर्टेंट है. सो व्हाट मेडिसिन्स आई एम टेकिंग टू रिड्यूस माय बीमारी इज नॉट द मेन थिंग. Implementation of the flexible operation is not the main thing. One of the main thing is that how I am monitoring for the future life. That is also very important. This will come from the additional sensors both in the turbine area. क्योंकि turbine में जो state monitoring system है, तो जो एक state monitoring system पहले होता रहता था पहले के जमाने में, उसके बाद next state monitoring system आ गया है. वो जो state monitoring system है, that cannot take this part. उसका वो anticipatory action उसके अंदर है ही. तो लाइट मतलब वो क्या दिखा रहा था उस समय में, रानी में कितना स्टेट जनरेट हो रहा है वो बिंदी करके कार के ऊपर दिखा रहा है. ग्रीन लाइन पे है तो आप कंट्रोल कर सकते हो, रेड लाइन पे है नहीं कर सकते. बट वेयर इज दैट रिकॉर्डिंग हाउ वी आर फीलिंग द मशीन. सपोज समबडी इज फीलिंग द मशीन रनिंग द मशीन इन द रेड जोन बाईपास करके, ये दैट इज फ्लो. तो उसमें कितना लाइट कंज्यूम हुआ ये कहीं रिकॉर्डेड नहीं है. न्यू सिस्टम विल गिव यू विल कंटिन्यू टू शो कि you can feel anybody, but only thing is that इसमें लाइफ उसका कितना बर्बाद हुआ है, इसका लाइफ का कंसर्न वहां बहुत वीक. इसीलिए नया जो मॉनिटरिंग सिस्टम है हम लोग का दो ही टाइप का है. एक वी आर एक्टिंग ऑन अ सॉल्यूशन, टू थ्री सॉल्यूशंस वी आर एक्टिंग solution. All the functions are not given to other or it is actually depending on a lot of that. And second is the monitoring system we have not supplied to other, we have not something different. Probably we will implement it there. So, but Satali are implementing this so this is something that you need to know. Thankful to you people, everybody, APL team for giving us the opportunity to talk to you, open up the ज़्यादा लिखने का वो हमको डिस्कशन कुछ आपका होगा हमारे ज्ञान प्राप्ति होगा वेरी मच. बट लाइक टू लिसन फॉर माय इंडियन रायगढ़ टू रायगढ़ और इंडियन रायगढ़ टीम आल्सो they are already using the system. Some difficulties are definitely they are facing, some difficulties we have solved, things are going in process. क्योंकि एक साल तक तो इसका प्रोसेस मॉडिफिकेशन चलता ही रहता है. ठीक है
तो सर लेकिन इसमें जो है आपने जैसा आपका really it was a nice presentation, but you know what are the measures and how you will achieve this 3% trap rate?
Sir, I have not on a public forum. It is basically क्या है ये machine to machine depend करता है. It is not a generalistic solution. I have already submitted the requirement for APL to Amit. तो अभी यहाँ नहीं है, Amit बना हुआ Amit के through संजीव जो आया था. So already we have submitted our technical offer, and after a lot of discussion, we have agreed on a joint phase. Okay, pocket assessment requirement and actual requirement. So these are the two things. One point I want to tell that people are a little bit confused in underneath all that APM that NOx system. The NOx का क्या हाल है? Basically ऐसा है NOx का modification से जो है ये चीज का जो है It is not in line with the requirement of other competitors. They are only modifying mostly in the Barnard modification. ठीक है? हम लोग Barnard के ऊपर में प्रेशराइज नहीं है. Barnard हमारे लोग windows modification. So windows modification is more important for us. Not for better rather than the Barnard modification itself. So the BHL solution will be low-load enriched Barnard along with the windows modification. That will give you the NOx solution along with the flexible. दोनों को एक साथ में अगर देखना. Otherwise, NOx में अगर आप अगर theoretically देखोगे तो कोयला कम जलाने का कारण आपका तो कोयला परसेंटेज कम होगा. कंडेंसेट करने से आपका फायदा होता ही है. उसमें अभी अगर आप दिन में 3 बार अगर कंडेंसेट करने का करते हो ना तो एक साल में ये पैसा हो सकता है. आपका जेब से कोई पैसा जा रहा है. ये कैलकुलेशन भी हमारे पास है. इसमें से एक इसका डिटेल चेंज होता है. For 1 year, the machine which is running, give a rough figure, the machine which is running at our 80% PLF throughout the year, and if it has connected probably 2 times a day for 1 year of operation, with slow driving, you can repeat that out. Then he gets a benefit of around coal, which is worthy of 5 crore rupees or year, keeping the coal cost at 300. Around 5 crore. So this is definitely funded. Otherwise, you will lose. Only thing is, if you don't do it, but आपको क्या है? आप lose कर रहे हैं. आप ये 5 crore रुपया भी आप implement कर सकते हैं. That's how the market engineering has been played by many of the operators. I am not given for a market engineering. I have never spoken a single line on that. So I was told that's why I have to take this. I am trying to plan that. Thank you very much for that. Passport एक 600 मेगावाट मशीन में I think 5.8 is the he has taken many inputs. CA has taken many inputs from many OEMs. And finally, they have averaged it out in their modification book dated 24th of April. So they have SOP for 40% and SOP for 55%. They have the compensation mechanism. The compensation mechanism for the 55% load, they have given the average cost of 10 crore, and for the 40% load, along with the more modification, 30. This cost is not the BEA cost. I cannot give you the BEA cost, but this is the average cost they have taken from all the manufacturers and others. From 30 crore investment, CRC is likely to agree to do for the so we have do not record it. Do not record it one thing. I will tell you, please do not record it.
Recording stopped.
ये recording बंद किया है, start किया है. This what? ये तो उल्टा बोला. उनके जी से दुनिया का खोल दिया है. इसका पता है. Baseline calculation का उन्होंने calculate किया 10 और 30. I don't believe in the person. My personal. और सीए का सर्वे बुक इसीलिए क्योंकि सीए जो होता है हमें वो सुनना पड़ता है. हम तो ये नहीं कर सकते आप ऐसा क्यों कर रहे हैं. हम नहीं कर सकते. ओनली आइटम एक ही बात है और यही हम करते हैं. मेरा ये नहीं होता है. मुझे कॉम्पेंसेशन मैकेनिज्म में जो मुझे मालूम है ऑलरेडी 10 crore and 30 crore. So what that includes the modeling system also. That includes the models. That includes the models. They have taken the average costing from BHEL and other 3 major vendors. They have taken the average costing. That's the model one. I know the one. That question. इसका पैसा कटता नहीं. ठीक है. Thank you very much. Thank you. देखिए and here is present here. DB power का तो यही है. सकारात्मक की बात किया बहुत दिन बाद में पता ही नहीं कि सकारात्मक हुआ बोल रहे हैं. सब खत्म पहुंच जाए तो नहीं पता था बस ठीक है सारे जैसा भी हमारे इतना बताना पुराना पुराना हिस्सा है नहीं होता तो I have to work with NTPC for something long time all the 8 years of NTPC believe he also business from all the days औसत में और यूनिट मिला के 39 साल रीजन में काम किया 39 years कुछ सीखा होगा वो किसी को कदर करते हैं अच्छा now he is taking my test I'm very glad that for nice thank you
Thank you very much, sir, for your excellent presentation and successfully implementing this flexibilization in various units of various capacity. And your
Recording in
advice was-
progress.
Your advice was very informative, and it was a intervention with a very positive side as a motherhood approach, especially carrying the machine life. When you are going for these transient regimes, new operating regime, you should not have the impact of the life of the equipments that has been told in very nice way and lucid manner to understand all of us. And with these few words, once again, I thank you, BHL team, for ready to offer this technological solution to face these challenging conditions in a more cost-effective manner. Hope you will be all utilizing their services in due course of time. Okay, with this, and after this post-lunch, you will be having 2 technical sessions, and one session will be delivered by Siemens, and another session will be delivered by Adani Raigar. So now we can break for this lunch, and again we can assemble back by 2:30. Okay. So thank you very much, sir.
Recording stopped.
यार हाँ मैं गलत बोला हूँ एक ही बता लेना ऐसा है तो अगर मैं किसी जगह पे गलत बोला हूँ तो ये नहीं पता चलता कि मैं अभी तो मेरा नाम क्या है ये बोल के आज लोग मेरे को
ये सब हम लोग के लिए नहीं रहता क्या, ये सब प्रेजेंटेशन होती है हमारा? कल तो रहा ना?
इंट्रोडक्शन क्या है?
अच्छा, जाने वाले थे क्या वहाँ? हाँ तो यार कौन है, क्या अरेंजमेंट की? बता दो। Right, इधर करते डिटेल्स को बैठा चार्जिंग क्या है क्या करूँगा आपको इधर बैठ ये ठीक है हेलो अरविंद सर ये कंडेंसर वैक्यूम पंप 1 पंप में कैंसिल कर रहा हूँ
पेनिट्रेशन हो गया है फ्लेक्सिबल ऑपरेशन का देने के लिए। हाँ? कहाँ? चौथे के लिए खाना है।
नहीं आएगा। पैसा हम लोग के लिए नहीं है। A+B. Andy Patel. Training. Flexible operation. from the Siemens. Mr. Umang Swarup will present the solution on the flexibilization online. I request Mr. Umang Swarup to present
Hello. Hello.
Yeah, Umang Swarup ji, you are audible now.
Okay, sir. Okay.
Yeah,
okay.
and welcome in the workshop, please.
Thank you, sir. Thank you. Okay, sir. Now I will share my screen. Are you able to see my screen? Hello. Hello.
Yeah, it is. I think it's just started.
Okay, sir.
But
It's,
not visible now. Yeah, it is not visible now.
it's not visible now. Okay. I will share once again. Wait.
Yeah.
Is it visible now?
No, no, it is not visible.
Still not.
Yeah, this caption that he has started screen sharing, but it is not visible.
Okay. Okay. Let me. Let me share once again. Then let me check what is have. Is it now visible?
No, 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 it is not visible now.
Mhm.
अरे उतना टाइम लग जाएगा.
Let me. See. So the site can be able. I'm sharing it, sir, but again, I don't why it's not getting shared. Again, you are not able to see the screen.
Yeah, it is not visible now.
Okay, wait a minute. Wait a minute. Just give me 1 minute. 1 more minute.
Yeah,
Then.
yeah, please. But
Hello.
Actually, it is not visible. Can you
So
share
if
the
not-
PPT? Can you mail it?
Okay, I will mail that PP. I will
Yeah,
let
mail
me.
it. Mail it the zip. Zip it what?
Okay.
Yeah.
रिजॉइन करेंगे
आगे।
Hello. Sir, is it visible now?
Yeah, it is visible. Yeah.
Now it's visible?
Yeah, now it is okay.
Okay.
Mhm.
Okay. Sorry for
Recording
this.
in
It was
progress.
so we can start now.
Yeah, Umang ji, yeah. Please start.
Okay. Good
Thank
afternoon,
you very
everybody.
much. Yeah.
Okay. So we'll start with this very hot topic right now in the power industry, that is flexible operations. So I'm here representing this flexible operations team from Siemens Energy Gurgaon. So we'll talk about what is the main agenda, what is going across flexible operations, and what are the initiatives taken by the government. And then we'll jump into the solutions, what Siemens and so which I've been showing, and this is a very prominent scene in the industry right now, and everybody is seeing this curve, the duck curve. So maybe you have been listening from morning this duck curve, that we have to go down and then we have to go up at the night, and solar has to kick in the daytime. So we need this faster ramps and faster ramp up, ramp down, and minimum load to cater this situation. So I will not stress this upon once again, because it is a very general topic now here in the workshop. So yes, doing so, what we have to see, we can see up to that we have to go this power plant have to go a technical minimum load up to 30%, but as CA guideline has stated about 40% to go down, and they have stated it with different ramp rates. So 100 to 75 we have to go with 3%, from 75 to 55 we have to go with 2%, and 55 to 40 we have to go with 1%. So what we need we have to have this technical minimum, that is 40%. We have to have more higher ramp rates, and for doing so we should have better efficiency of the unit, and quicker starts and stops, which is the
need of the hour. So this is the market leadership what we have done till now in India. So we tested NTPC Dadri and we achieved 40% technical minimum, and we did it in 2018. And we implemented our solutions. We gave the recommendations what solutions to be implemented at NTPC Dadri, and then the implementation one was done in 2019, and recently we have concluded its PG test for NTPC Dadri. And after that, we did a test at Tata Marathon, that is 525 megawatt, and we tested it at 36%. And the implementation is under discussion with Tata. And then we did a test with IGF and VGB with the government initiative at DVC Andal, and there that was a 500 megawatt unit, and we achieved 32% technical minimum during the test. So what are the part load issues what we have seen till now by doing these tests in different plants? So the main challenge what we face still is the fuel composition. As we know, every unit is getting a different type of coal, and all inferior quality of coal with a lot of ash content into it. So yes, fuel composition is a major challenge. The fuel supply system, the mills at lower load, and the air control at lower load, proper combustion at lower load. This is a challenge which we face during this technical minimum at 40%. And this combustion quality is one of the parameters. Second is APH outlet, the backend temperature, it goes low. Major issue there. And for supercritical units, if we talk about, then yes, that evaporator stability is a concern there for supercritical units. So moving on, this is the challenges what we face till now. So we'll move on to what solutions what we have, Siemens Energy has to offer. So while giving solutions, what we do it in a phase wise manner. The phase is like this, that we first study the unit where the implementation is to be done. The study of the unit is done, the control loops, the O&M practices, and what is the design. So we study all this for a single unit. And then after this studying, we do a test, that is a pre-test, what we call as a min load test, and we try to go down till what minimum load we can go without any interventions, software or hardware. And we try to go down what minimum is possible, and we try to achieve what ramps is possible in the existing unit. We collect all the data and then come back, analyze, and then we give solutions to it, that these many solutions are required for the unit to go down. So we have interventions such as combustion optimizers, temperature optimizer, soot blower optimizers, fast ramps, and technical minimum. Some as conduction throttling, some mill schedulers or unit control. So these type of solutions are implemented. All are not implemented to all unit. One size doesn't fit all. So every unit is different. So according to the test, what is the outcome? We try to we try to give that this solution is optimal for you, for the unit to operate at 40% with that ramp. So that deployment is done, and after that, a digital tool is deployed to monitor the unit and give a feedback to the client that yes, uh, during this 40% of load, what are the problems, efficiency point or performance point of view, what you are facing. And this is done by our thermal twin. And we all know going below that 40% and ramping it and ramping up and down, there are stresses on the boiler. So we deploy the fatigue monitoring systems to the unit to calculate the real time stresses in the unit. So after the test is done, so we see what solutions can be deployed. So we'll now discuss what we will discuss few of the solutions what Siemens Energy will offer after the testing. So this is one solution, that is a temperature optimizer. We have a state of art space controller, that is a P3000, what we call it as, and it is a temperature optimizer. So yes, during the ramp ups and the ramp down, what generally in plant we do is we set a lower set point to the temperature, saying that the temperature should not go above a certain limit and should not touch the material limits. So what we see here, the band for the steam temperatures is, the band is very large during this now the conventional unit. So after, what temperature optimizer does is it stabilizes my temperature deviation into a certain limit. So this limit is decided when we do the test. So what, up to what range we can uh, we can settle down this temperature fluctuations, and doing so we can raise up the set point to the original set point of 540, or say whatever the design temperature is. So this is one of the solutions what is implemented for control of temperatures, giving us a good temperature at the boiler outlet. Next, moving on, what we have is a soot blower optimizer. Soot blower optimizer is again a solution where in general the plant philosophy is to deploy soot blowing in a in a sequential manner, so that starting it from wall blowers to LRSBs, and they do it in shift wise basis. So what we do here is we do it on, not uh, in a in a way of sequential way. It is done in a incremental soot blowing. What we do is we cross check the heat transfer between the two surfaces, and then the controller says, yes, now here the heat transfer has gone poor, so we need soot blowing in this area. So accordingly the soot blower is done. So other than getting this type of curve for soot blowing, we get a constant curve of flue gas temperature profile. So this helps us to get a good temperature at reheater and superheater, and also the temperature imbalances in the boiler is reduced, and the boiler slagging is also reduced by the soot blower optimizers. And this temperature optimizers and soot blower optimizer both have been implemented at NTPC Dadri. And this is next solution is for the min load reduction. So this is also the solution which has been implemented at NTPC Dadri. So yes, this is again the unit controller which helps us going down the minimum load for 30% or 40%, say. And yes, it is what we do here is, for all, is it sudo or is it temperature optimization, or it is a min load reduction as optimizer, they all can be deployed upon the existing DCS. And how they work upon the biases they give upon the original signal which is being sent out. So this can be deployed upon your existing DCS, and it is in a way a separate module is fitted in the existing DCS, and we can communicate with the help of Modbus. And yes, temp we do not need as such a shutdown for implementing this P3000 for this min load temperature optimizer or soot blowers. Going forward, there is one more solution. What is this is a primary frequency control solution. This is condensate throttling. Again, it has been implemented at NTPC Dadri. This condensate throttling, this is the utilization of the balanced energy in the system, stored energy in the system, to generate the extra power. And if you can see the curve here, what we do is we first try to throttle the turbine valve, hereby increasing the pressure, but the flow gets reduced, so that so the reduced flow is compensated with the help of cutting off the extractions. Say LP heater 1, we cut off the extractions and the pressure has been raised. So we get, instead of getting a profile of lower load increase, we get a more steeper curve, and we get a faster load ramp. And when the boiler is ready to give that pressure again, so we take up that load after the firing is attained in the boiler. So this is a type of throttling which has been implemented, and the results are good at NTPC Dadri. So as I said, yes, it can be implemented on any DCS. So it can communicate to any DCS, whether be it's third party or Siemens DCS. So yes, we can communicate with any DCS, and it can be implemented on top of above the existing DCS. So talking about these solutions, the comes is the fatigue. Yes, we know ramping up and ramping down give us more fatigue in the system. So yes, this boiler fatigue can be calculated. It we cannot assume it. Yes, sir. Is there any question? Hello. Hello.
No, sir, you can go ahead.
Okay. Okay. So ramping up and ramping down is causing us the fatigue, which is what we call as the cycle fatigue, or the low creep fatigue. So yes, this can be calculated, and this is done by our fatigue monitoring system. So what we do is, in this we do a RLA of the existing unit, and then come out of the remaining hours of the boiler, and then we deploy the essential instruments if required for the thick wall components, such as drum or headers or T pieces. And then this FMS take up all the temperatures and pressures required for its working, and they give us so this is also installed in NTPC Dadri. So it's again same, it can be communicated, this is through a OPC server, and it can calculate both creep fatigue and the low cycle fatigue. And the critical components what we try to measure is for headers, manifolds, drums, separators, and Y pieces, T pieces, and the temperature pipings. And for turbine, same, we have a EOH counter, which will give us the life consumption for this ramp up and ramp down in real time. This is for turbine, the EOH counter 4. And after this implementation, what we suggest to our clients is to give us the monitoring, and we implement our digital tool, which is our in-house tool based on our in-house physics-based model, which is called the Krawal. So we integrate the HMBDs related to the turbine, and the design of boiler is integrated into it. And we can take the real-time values from the DCS, and we can give you the real-time heat rate and real-time performance of the equipments. So this is deployed, and we can monitor the system at part load and full load both, to give us what and recommend what is going wrong in the system. So that's it from my side. If you have any questions, we can discuss.
Audience, if you have any questions, you can ask. The session is now open for discussion. If you have any doubts or clarification related with the products as well as the services provided by Siemens, you can raise the questions.
Hello.
Yes, sir.
Sir, you have mentioned that you have done the at DVC and all at 32% technical minimum and 3% ramp rate.
Yes.
So is it the ramp rate is from technical minimum to full load or some
No,
specific
sir.
band?
No, sir. Technical minimum till 55%. Till 55% we tried to achieve, but that 32 to 55 we achieve 1.5 only, and then above 75% we achieve 3%. What is as per the CA guidelines, 75 to 100%.
So have you done the test from technical minimum to full load? What
Yes,
is the ramp
yes.
rate?
So the procedure is like this only. When we go down, it is a 3-day test. So and the first test, what we do, we try to go down to minimum load. Once we reach this minimum load, the second day we try to ramp it and ramp down. First we do to ramping till 55. What is your original technical minimum? And then we go down from 55 to 40%, and then we go straight away from 40 to 100. And trying to achieve what is the ramp is guided by CA. So, but what we have done in DVC and all or any test we do, it is without any intervention. It is original what you have at the system. It is on the tuning what is being done still in the system currently. So we try to capture that, and then after we deploy our solutions to achieve the stated ramps as per the guidelines of CA.
Suppose we have to go from 32% to 100% full load. What will be the ramp rate, expected ramp rate?
So it is same from 30%, from 40% to 55, we will achieve 1%, and 55 to 75, 2, and from 55 to 100, 3.
See,
So
normally during the light up and synchronization, nobody stops at 30%, 40%, 50%. Gradually, we will gradually synchronize the unit and gradually go up to the full load, depending upon the stress evaluation and other criteria.
Correct.
So in that case, suppose we have to go from 32 to 100%.
Yes.
What is the possible maximum ramp rate?
Sir, see, currently, without any interventions, without any deployment of solution, 1% or 1.5 can only be achieved.
1 to 1.5%, no?
Yes, without any interventions.
Without any
If we
interventions.
yes.
Okay, thank you.
For this fatigue calculations and other thing, do you proposing some additional instrumentation?
So yes, it is up to the condition of plant, what level of instrumentation is installed at the unit. So we do it accordingly. We visit the site and then we see whether the instrumentation required for the calculation of fatigue is sufficient or not. So accordingly, we give the suggestions that yes, instrumentation is required or not required.
In most of the cases, it is standardized.
Most of the cases is standardized, and
what type of instrumentation is there? So, what is your experience with this?
So with this, in regarding this, we have deployed it at NTPC Dadri. So there we have not installed any extra instrument till date. Till date, the fatigue, the calculations and the results coming out is still satisfactory. So we have not added any extra instrument to it.
When it was implemented in Dadri?
2020.
2020.
Yes.
And so it is now 3 years in operation.
Sir, 2020, but yes, not in 3 years in operation because they were not getting the lower load till 40. So we cannot say that yes, it has been continuously being operated at lower load and it is being tested. But recently, we have completed the first PT test, first phase of PT test for NTPC Dadri. So we have tested that.
From present technical minimum to full load, are they doing it at 3% ramp rate? And what is their experience in doing at 3% ramp rate?
So 3%, they are doing it from 75%. 75% to 100.
So what is the experience on?
So it's good because of they are having condensate throttling also, and it was installed earlier before this technical minimum thing came into the picture. It was already installed at NTPC Tatari, condensate throttling. So they were having better RAMs earlier only. So 75 to 100 they got a good 3% RAM.
Is there any study done how much metal temperature extraction was taking place earlier and after these modifications and achieving 3% RAM rate?
So after implementation such, but we can come back with something such as NTPC's experience. We can come back with that, but as such, no study is not done till now. Any specific study.
Thank you.
Any other questions, please? Connected, right? Sir, from Sasan team, any other questions, sir? Morning also you have raised one question, but we could not able to discuss, sir. Can you please ask the question, and panel members are available so that they can discuss and we can they can provide the solutions. Sasan team, sir, are you able to hear me? Connect nahi hai. अच्छा connect nahi. Okay. Okay. Thank you, sir. Thank you very much for your beautiful presentation. And it was containing a lot of innovative solutions to address this flexibilization in thermal power plant. And you have shown a lot of products as a retrofit products which can be introduced in our plant, existing plant system without much modifications. And thank you for your products.
Hello,
And
sir.
now we will go to
able to
this
hear
new
me?
session. Another session.
Okay, sir. Thank you, sir. Thank you.
Yes. Sir, one more question, please.
Sir, I am from Sasan. Are you able to hear me?
Yes, sir. Questions? Technical minimum testing 40% start yield.
Prakash Upadhyay, na? Sir, you can ask the question directly. We are unmuting. What is the name, sir?
Sir, are you able to hear me? हाँ. Sir, मेरा क्वेश्चन है during the testing at technical minimum at Dadri, at 40% load, what was the pH inlet or outlet flue gas temperature? Sir, did you get my question?
Please repeat your question.
Sir, please repeat your question, sir.
Sir, I am repeating question. Hello.
हेलो हेलो आवाज आ रही है सर?
Yes, very much, sir. It's audible.
Yeah, thank you. Sir, my question, during the testing of technical minimum at Dadri in 2018, so what was the APH inlet and outlet temperature at 40% load. Do you remember that? The flue gas temperature. I'm asking the flue gas temperature. And which month the testing was done in Dadri, sir?
प्रकाश
यस सर
क्वेश्चन है ना एपीएच इनलेट एंड एपीएच आउटलेट टेम्परेचर कितना है ना टेक्निकल मिनिमम लोड पर
यस सर यस सर
ठीक है सीमेंट से बात वो डिस्कनेक्ट हो गए हैं मैं बात करके बताता हूँ ठीक है
ओके सर
ठीक है और कुछ क्वेश्चन था
Second question was, sir, during the test, did the operate HP bypass or without HP bypass operation?
फिर से पूछो
सर एचपी बाईपास उस समय क्या ऑपरेट किए थे या नहीं
एपीएच बाईपास डैम पर
एचपी बाईपास एलपी बाईपास
एचपी बाईपास एलपी बाईपास एक मिनट रुको मैं देखता हूँ
because our people also they are आरती साल से पहले उन्होंने क्या किया था जो क्या बोलते हैं फर्नीचर शॉपिंग को इन्होंने अलग से पैकेज लगा के कर दिया मतलब 80% जो फ्लेक्सिबल ऑपरेशन का जो रैम रेट के लिए सपोर्ट करता है वो पहले कर दिया विदाउट मतलब आप सिर्फ वन क्वेश्चन विदाउट जो हुआ आपने मेरे को पूछा था विदाउट support of furniture burning, what is the maximum achieved RAM rate? That is not encouraging. That's why we get अलर्ट डालने 2018 में जब हुआ था उस समय में लोग जो कि हमारे जो टीम मेंबर एचपी बाईपास को ट्रांसफर करके रैम पैनल करना है तो कॉमन करना हो सकता है वो हम उसको मतलब कंपनी ऑन ऑफ करके प्रैक्टिस किया तो जो हम लोगों ने that is not the correct way because it's a cement as well. Normally allow एक एक केस में तो बिल्कुल नहीं हम इसको एमएस ऑपरेट नहीं करते हमारे यूजू की डील का
And actually, Siemens has decided now, and we will put up a question with the Siemens sir and we will come to you. Thank you for that.
Now a request to Adani team, Adani Raigar, to present that presentation on flexibilization and their experiences and the technological solution in implementing this in power plant.
Good afternoon, all. My name is Sandeep Nayak, and my colleague, I am from CNI department, and my colleague from Operation Department, Mr. Ravi Gom, we will be presenting you the uh, uh, flexible operation and what are the problems faced and what are the activities which is done at Raigad plant. So this is the contents of the presentation. We'll go through the brief introduction of our plant. Next will be the APC system that is installed for this flexible operation. Then what are the control loops that are in APC mode? Then the achieved ramp rates and the results of the flexible operation and what are the logic modifications. We'll be going through this in this presentation. So this is a brief introduction. As you all know, this is a 600 megawatt subcritical thermal power plant supplied by BHL. These are the technical parameters of our plant. This is the project milestone. This plant was actually COD was completed on 1st April 2014, and at 20th July 2019, Adani Power acquired through NCLT this APL REGL. REGL actually is the previous name. Now it is APL Raigad. So we'll start with what is flexible operation at Raigad. So this is Adani Power and BHL have mutually agreed. So these are the contract things. Existing, we have max DNA DCS, which is also supplied by BHL. And for the flexible operation, a separate system of APC control was supplied by BHL. So what is this APC control? This is actually a fuzzy, as sir told, fuzzy logic based control where we have multiple inputs and the outputs which are generated, it is directly going to the BHL DCS, and through that only the operation and the operation of the parameters and the parameters which are getting deviated are controlled through this system only. This is actually a separate package. I'll show you the panel that is installed in the and the communication between the existing DCS and the Walmart DCS, how the communication is going on. So this is the brief introduction. Advanced process means the set of techniques. This it's the same. The fuzzy logic where there are multiple inputs and the outputs are the logic is getting generated and the output is integrated in the existing DCS logics. So these are the various controls, combustion and superheater temperatures, and other analog controls which get affected during the ramp. This is the network diagram of the DCS. These are the two servers. This is the network diagram where we have two servers installed. These servers are actually taking data from the DCS. This I'll actually go. This is the panel. So this is the controller जो है जो बताया था. These two are the controllers, and then this is connected through MaxLink OPC से existing DCS में signals जा रहा है. तो ये एक बेसिक एक funnel rate का कंट्रोल कैसे किया है इसको दिखाया गया है. अब बताओ.
Hello, good afternoon. This is basically the summary of the flexible operations that we have conducted at APL Raigad. So we have conducted these tests. Actually, the earlier the guideline was 3% throughout, from 100% to 55%. So based on that, we have done these trials. Later, the guidelines were changed. That is from 100 to 70%, it was 3%. And then 70 to 55%, it is 2%. And below that, up to 40% is 1%. So we have not yet done any trial of the third stage, that is below 55% of the load. So whatever the data displayed here will be of the first two stages. So we have conducted the tests from 11th October to 18th October. Total 45 numbers of trials were taken, out of which 23 were ramp downs and 22 were ramp ups. The load range is specified, that is 60 to 95%. That is our unit is of 600 megawatts, so it translates to 360 to 570 megawatt. So first ramp down was given from 570 to 470 megawatt, and then 450 to 360 megawatt. Ramp up test was given from 360 to 450 and 470 to 360.
हमारा वेट बड़ा था। कितना झूल जा रहा बच्चा, कितना झूल जा रहा बाहर। अच्छा कोई बात नहीं, वो बेल के साइड में ये मैट्रिक्स रख के ना।
Yeah, ramp up and down were also conducted with condensate throttling and HP heater extraction on off. But this ramp that we have achieved doesn't include the effect of these two methods. These were totally separate things that we did. It is majorly due to the response of the governor in catering to RGMO response. So in that we can utilize these two methods to gain a quick response in load. And during the test, obviously all the CMC loops, all closed loops were put in auto mode. During the ramps, we have ensured that no manual intervention is being done. And primary frequency response test was conducted 5 times, in which we have throttled the condensate main control valve to derator about 20 to 25%. These were the loops that were put in APC mode. SH temperature, RS temperature, burner tilt, SADC, mill fuel air dampers, airflow biasing, fuel air ratio, O2 set point bias. Some of these are purely introduced through APC only, that is airflow bias and O2 set point bias were not originally there in the MAX DNA, but due to the introduction of APC, these two entities appeared, and LOFA control and OFA control were also in auto. This is the gist of the ramp rates that we have achieved. Most of the trials were in the range of 2.7 to 3% per minute. That is 16 to 18 megawatt for both ramp ups and downs. And maximum ramp rate achieved is 3.21% for ramp up and 3.12% for ramp down. हाँ, बहुत चेंज हो जाता है सर. Yes. So during PFR trials, that is by condensate throttling technique, the load ramp up of 32 megawatt was achieved. That is 5.3% of base load. And during PFR trial using HP heater bypass technique, load ramp up of 47 megawatt was achieved. That is 7.83% of the base load. Observations, as we have all witnessed, these are general observations. MS temperature variation was about plus minus 12 degrees during ramp ups and downs, maximum 551 degrees. It is nothing extraordinary, means it is not a major excursion for our units. It is a normal value, 551 degree. HRS temperature variation was also about plus minus 12 degree during ramp up and down, maximum 548 and minimum 512. After the ramp down, it dipped to 512. Spray system was also in service. Furnace pressure variation was about plus minus 22 mmWc during ramps. Drum level variation was also minimal, 25 mmWc during ramp up and ramp down. Wind box DP is of particular concern.
Sorry, sir.
It reached 250 mm. In the initial trials, it even went to 40 mmWc, but later on, after the proper tuning through APC, then DP was achieved the 50 mmWc during load ramp down.
Hello, hello.
Sir, it is a set point is already there, but during ramp downs, it overshoots the set point by a certain amount. So there were some deployments for this purpose. That is, we have to lock. Sir, actually, as part of the tuning exercise, the airflow control loop was also tuned to a way to response in a particular manner. So airflow also was cut by a particular rate for that particular operation during ramp down only.
सर जो पीएफआर टेस्ट किए थे सर आर यू
या बोलिए बोलिए
सर जो पीएफआर अभी जस्ट बिफोर स्लाइड में जो दिखा रहे थे पीएफआर टेस्टिंग उसमें कंडेंसेट थ्रॉटलिंग जो हुआ है वो ऑटो में हुआ है सर मैनुअल में यस this one sir point number 3
yeah the throttling was totally in auto. There was a button defined to enable the condensate throttling, that is PFR. So when we click on that button, then the rest of the process happens automatically.
Okay, any extraction also throttle during that period?
No, condensate throttling was separate exercise and HP heater bypass technique was separate. Both the techniques were separate.
Okay.
And O2 variation was from 2.8 to 6%. LTSH metal temperature excursion limit was breached during low load ramp up. It is also a normal general phenomena whenever we bring the load down of our units, then this scenario appears even without ramp ups and ramp downs. During PFR test, condensate throttling, during condensate throttling exercise, derator level dropped from 500 to minus 150 mmWc. That is below MDBFP auto start permissive. So that is an issue that needs to be addressed. And during HP heater extraction valve throttling exercise, HP heater 5 and D extraction valve were stuck in closed condition. So after a particular time when they need to be open again, then it got stuck. So it is majorly a hardware issue, so that we are working to resolve at our site level. Normal derator level कितना रहता है? Derator level कितना रहता है? 480 mm रहता है. So now, so for the purpose of test, that is why we have raised the level to 500 before the test. ये सर वही प्रोलॉन्ग्ड ऑपरेशन नहीं रहता है ये, मतलब जितनी देर में आपका लेवल फ्लक्चुएट होगा उतनी देर में सिस्टम नॉर्मल हो जाए, वैसे ही हम लोग सोच के करते हैं। ये जो प्रॉब्लम आया जैसे उसके अगेंस्ट हम लोगों ने क्या क्या किया, थोड़ा जैसे O2 परसेंटेज एज पर स्टीम फ्लो, तो इनिशियली जो एज पर कर्व उसमें जो फिट था ऑलरेडी मैक्स डीएनए डीसीएस में लॉजिक्स में, तो 3.56 to 8% का कर्व था based on the MS flow. So later it was slightly modified to 3.4 to 8%. And fuel ratio was previously fixed at 4.83%, and it was made flexible 4.8 to 6% up to 40% of MS flow. Coal feeder minimum flow locking was there in all mills, that is, it will get locked at 50%. So it was also modified that lower elevation mills, that is A to D, are locked at 60%, and upper elevations were locked at 55%. These were all in response to the results that we seen in those 25 trials, 45 trials. So whatever we were 7 वर्किंग है, 2 स्टैंड बाई। विंड बॉक्स डीपी में कोई लॉकिंग नहीं था एयर फ्लो पे, तो बाद में उसमें एफडी फैन का जो ब्लेड पिच है उसको लॉकिंग प्रोवाइड किया। जैसे ही ड्यूरिंग रैंप अप और डाउन अगर डीपी लेस देन 60 अप्रोच कर रहा है, तो जो एफडी फैन का जो भी ब्लेड पोजीशन है उस टाइम पे वो वहीं पे लॉक कर देगा। दिस इज जस्ट अ प्रिवेंटिव मेजर, because previously it was going up to 40 mmWc. After locking, it has improved to 52 mmWc. PA header pressure was previously kept at manual with set point around 790-800. Then auto curve was introduced so that it can be controlled from 790 to 825. And auto and manual selection was provided in DCS. LOFA, OFA, there was no locking earlier. And wind box DP goes below 60, then it will be 100% closed. On-off selection for PFC was provided in DCS. PFC in service and PFC normal on indications were provided. And load ramp up with PFC alarm was also generated. Derator level control valve, that is CDV 22. It was throttled to by 15 to 20% during ramp up and 75 to 70% during ramp downs for 2.5 minutes only. And minimum position was locked at 20%. And in any scenario, if CEP discharge pressure goes below 20 kg, then changed from 22 to 20%. Similarly, in HP heater extraction cutting section, HP extraction valve was closed one by one in 30 seconds interval within 1.5 minutes and opened one by one after 5.5 minutes. These are the logic modifications that were done majorly in our units. This is the ramp test of 15th October that
सर
we did.
जब एक्सट्रैक्शन आप थ्रॉटल कर रहे हैं
जी
कोई भी वाइब्रेशन हाई हुआ है क्या?
Can you repeat please?
During the PFC, when you throttle the extraction, S-filter extraction, टर्बाइन का कोई वाइब्रेशन बढ़ा था क्या?
Turbine vibrations?
Yeah.
So now there was no major observation as such of increasing turbine vibration. So this is the 460 megawatt to 550 megawatt ramp up trial. So we achieved the desired load response in 4 minutes and 52 seconds.
इसमें एक्सट्रैक्शन क्या 1 by 1 क्या तीनों एक्सट्रैक्शन आप आउट करते हैं क्या?
नहीं, इसमें क्या है कि एचपी हीटर हमारे 2 स्ट्रिंग्स में है.
ओके.
जैसे 5A और 6A और 5B और 6B. तो उसमें जो है एक एक स्ट्रिंग का जो कट करने का है वो वाला बताया हुआ है उसमें कि पहले एक स्ट्रिंग को कट करते हैं फिर दूसरे स्ट्रिंग को कट करते हैं.
ओवरऑल दोनों एचपी हीटर आउट करने के बाद उसमें कितना लोड का इंक्रीज होता है उस मोमेंट?
हाँ, एक मिनट पीछे वाली स्लाइड पे ले जाता हूँ. ये जो लास्ट वाला पॉइंट है इसमें,
तो यहाँ पे तो आपने एचपी बाईपास दिया था.
अब वो इसमें गलत लिखा हुआ है. एक्चुअली वो एचपी एक्सट्रैक्शन टेक्निक ही है. एचपी बाईपास में हम लोगों ने कुछ नहीं किया है.
ओके, थैंक यू.
हाँ, ये एचपी बाईपास नहीं, एक्चुअली एचपी हीटर बाईपास है. हाँ, तो एचपी हीटर बाईपास मतलब एक्सट्रैक्शन कटिंग ही है. Yeah, this was again the second trial, 470 megawatt to 560 megawatt. This time also it was achieved in 5 minutes and 20 seconds. See here the blue line shows the set point when the set point was changed, that is C&I command was generated, and the orange line is the actual load. So both are shown for clarity. And you can see the MS temperature and HRS temperature curve that is given above. How smooth was it? This is ramp down, during which we also achieved 3%, 555 megawatt to 465 megawatt. Here also the MS temperature and HRS temperature curves are very smooth. This is 470 to 560 megawatt. Again, 3.03% ramp rate was achieved. ये कहाँ से हो रहा है? This is the curve that was modified based on MS flow, O2 percentage curve. ये नहीं बढ़ रहा है. अभी बढ़ा. This is fuel to air ratio curve that was earlier fixed at 4.83%. So now it is variable as per fuel flow, MS flow, it will vary. हाँ सर. These are all different ramps. This graph is mostly the minimum that we have achieved in these trials is 2.3%. And the maximum we achieved is 3.4 around percent. See also the data for the next set of trials. Okay. Here, yeah, sir. Yeah, this is the page from where we make the APC on and off for a certain control loop. So here on the left side, the airflow control, earlier there was no such option to, and also this transition between DCS to APC mode is bumpless transfer. Means no parameters will be affected in any way. You can shift from APC to DCS in any time. सर वो एक्चुअली पहले ट्रायल था तो इसीलिए शायद नहीं किया होगा कि एक साथ सारा आ जाएगा. हाँ. Yes, sir. We will definitely coordinate. No, sir. Always on. It is kept always on. Always. Sir, sir, let me clarify. Suppose I have to bring the load of the unit down from 600 megawatt to 550 megawatt, and I have put the unit in APC. So when the unit is in APC, then it will do the things in a certain way. Means it will cut off the airflow in a certain way. It will change the set point of PA header pressure in a certain way. So it will do whatever is defined in the APC module. As per that, it will follow. But when we put it in the DCS mode, then it will be shifted to the old regime. That is, whatever the set point we have given, it will take only that set point. Means no variability will be there, like in APC is there. Suppose it will change the header pressure of PA header pressure from 790 to 825 in APC mode. But in DCS mode, it will simply take the set point that you have given to the system. But it will be variable. It will auto evolve, sir. The set point is ever evolving. Yeah, set point will be there, but the set point will automatically change, sir. Set point will also change. Set point will also have a bias in APC. That will be given initially when the system was in DCS. Suppose it was given 800 and then I have put the system in APC mode. So base set point will remain 800, but in APC it will change to sometimes to 790. Sometimes it will switch to 820. Yes, but it will not happen in DCS mode. So that is the difference. Sir, any loop can be put in any time in DCS or APC. All the loops will shift to APC. ये भी रहेगा. ठीक है सर. तो जैसा पीए हेडर प्रेशर का बताया था वैसे ही O2 परसेंटेज में भी एक बायस है जो सेपरेटली एपीसी सिस्टम जनरेट करता है. So bias will keep changing when APC is in service, but when we put in DCS mode, then that bias will be automatically off. हाँ, मतलब वही है कि set point will be ever evolving in APC mode, but in DCS mode it will be fixed as per the operator's input. हाँ सर, ये 45 times trial है. अभी भी रिपीटेबल है, बीच में हम लोग करते भी रहते हैं इवन ड्यूरिंग नॉर्मल ऑपरेशंस. Suppose as per BD's instruction, we have to ramp down the load from suppose say 570 to 500 megawatt. So for that 70 megawatt, normally we will need 2 blocks. Means 2 blocks में हमको डाउन करना रहेगा. तो हम लोग क्या करते हैं? We wait 1 block to pass by, and then after the second block is also half means over by half amount. Means 7.5 minutes are only remaining. Then we suddenly give the command of 70 megawatt. So it achieves the exposure accordingly. There.
It is a PFC की जो page है, में जो ऑटो में जो है, there is only a single button which is given and everything else is done in auto. The heater bypass is also here. यहाँ पे एक्चुअली दिस इज जो एपीसी का जो कंट्रोलर्स है, यहाँ पे देख सकते हैं कि दिस नहीं वो गलत होगा. Yes sir, this is sir told there were 32 new temperature probes were installed in boiler drum का monitoring. Yes. टेम्परेचर कंट्रोल के लिए कुछ नहीं लगा है, टेम्परेचर कंट्रोल नहीं. हाँ तो दिस इज सुपर हीटर कंट्रोल. यहाँ पे सर एपीसी एंड नॉर्मल जो डीसीएस कंट्रोल के बीच में जो चेंज ओवर है यहाँ पे दिखाया गया. तो दैट इज एपीसी पीआईडी एंड दिस इज द डीसीएस पीआईडी. तो दोनों में तो बम्पलेस ट्रांसफर जो बोलते हैं दैट हैपेंस व्हेनेवर वी चेंज द मोड. यस दिस इज द. अभी तो स्टेज सेकंड फर्स्ट स्टेज में 60% हो गया.
हाँ एपीसी में ही रखता है पूरा टाइम. हाँ नॉर्मल रनिंग में भी कांस्टेंट लोड पे भी एपीसी में ही रहता है. और ड्यूरिंग रैंप अप और रैंप डाउन और रैंप अप देने के लिए अलग से कुछ इसमें सेलेक्ट नहीं करना है. खाली जहाँ से सीएमसी में हम लोड का सेट पॉइंट देते हैं वहीं पे आप अगर पर्टिकुलर डिफरेंस से ज्यादा का सेट पॉइंट दोगे तो द सिस्टम विल अंडरस्टैंड कि इट इज रैंप अप एंड रैंप डाउन. हाँ 300 मेगावाट तक का सेट पॉइंट दिया.
उसको 40% तक भी
अभी 40% पे हम लोग का आने का है. किसमें? हाँ नॉर्मल चलता है. हाँ इवन 280 मेगावाट तक भी हम लोग जा चुके हैं नीचे में, लेकिन उसमें नॉर्मल ऑपरेशन में गए हैं, ऐसा रैंप के साथ में नहीं किया है. तो रैंप के साथ में करने के लिए अभी कुछ हार्डवेयर रिक्वायरमेंट्स हैं, वो जैसे ही हार्डवेयर रीच होगा साइट पे तो फिर आगे करेंगे. तो अभी स्टेज 3 वाला हमारा पेंडिंग है जो 40% जाना है, नहीं हुआ. Thank you all for listening to us, and thank you JIPT for providing the opportunity, and thank you sir for your valuable inputs.
Two minutes, sir, not more than that. So good evening to all of you. We have come to this concluding part of this one-day workshop on flexibilization, technological solution, and O&M practices. It was very wonderful and interactive sessions, and we had 4 presentations and 2 from operator's perspective and 2 from the manufacturer's perspective. And each presentation was containing its detailed information to tackle the existing condition or the futuristic condition, that how we are going to adopt this flexibilization in order to accommodate this renewable energy in our green grid system. So the presentations was containing a valuable information, and the first presentation was presented by JPL from the operator's perspective. It was a experimental investigation in a opportunity time, where they have captured each and every step, and they have recorded and what are all the challenges available in implementing this flexibilization, and what are the possible solution to tackle these things. And it was very captured very nicely. Thank you very much for your beautiful presentation, sir. And it was followed by a presentation by Mukhopadhyay sir and his team from BHL, from the manufacturer perspective, they have given a various solutions how this can be taken without harming the equipments, with a futuristic view of without affecting the without protecting the equipment health and safety in mind. It was a detailed presentation, and he has also addressed that the technological solutions as well as the cost-effective solutions from the BHL. And the third presentation was presented by Mr. Umang Swarap Siemens. And from the manufacturer perspective, they have given a lot of solutions which are implemented in various power station Dadri and DVC. And the fourth presentation was by Adani Raigar, again from the operator's perspective, the implementation of these flexibilization, and they have carried out a lot of effort in implementing it at more than 46 times. And the data is available, which is evident, gives and guidelines how it can be tackled in a more safe and optimized manner. So with these few words, I think that this workshop has served its purpose of creating a thought-provoking sessions and what are the ways and means and technological solutions and O&M practices are available to implement this flexibilization in due course of time. With these few words, now I would like to share the opinion. I would like to request to share the opinion of our valuable guest. I invite Mr. A.P. Trivedi, DB Power sir, to address the gathering about this workshop. Please, sir. Just to share your
सेशन काफी अच्छा था एंड खासकर साहब का जो यहाँ रहना थ्रू आउट तक, जो हम लोग का छोटे छोटे डाउट्स थे और काफी लॉजिकली टेक्निकली, जैसा साहब ने कहा कि प्रेजेंटेशन बहुत छोटा है लेकिन प्रेजेंस आपका बहुत बड़ा है, तो वो काफी अच्छा रहा। एंड देन ओवरऑल जो अडानी का एक्सपीरियंस है वो देखने के बाद जो भी लोग का हम लोग का कॉन्फिडेंस और बढ़ता है। खासकर जो उन्होंने कहा कि 15 मिनट वेट कर 5, 10, 7 मिनट वेट करने के बाद कमांड देते हैं, वो बहुत बड़ा एक कॉन्फिडेंस है और हम लोग के लिए भी है, और वो शो करता है सर कि हाँ उनको सिस्टम पे भरोसा है, तो एक बहुत बड़ा है अचीवमेंट है। एंड बाकी ये JW से है ना, वे भी ये लोग भी काफ़ी अच्छा आइडिया मिला होगा कि सोच के आए होंगे मोस्ट प्रॉब्ली, मुझे लगता है कि उनको वो चीज़ इनपुट मिला होगा, तो इधर बैठे हुए हैं उधर उधर कर रहा हूँ। बट आप लोग कुछ क्वेश्चन नहीं पूछे, क्वेश्चन बहुत कम लोग पूछ रहा था। मेरा ये चीज ये मैं तो बोलूंगा, वो कंप्लेन बोल लीजिए या जो बोल लीजिए कि जब तक क्वेश्चंस नहीं आते ना, सर कितना ओपनली बोले, ये मत सोचो गलत पूछ रहा हूँ सही पूछ रहा हूँ, जो मन में आए पूछ दो। और जब तक वो नहीं पूछता है कोई ना, तो मेरा मानना होता है कि वो फिर तो सोचता रह जाता है, और बाद में सोचता है कि अब पूछना चाहिए था। सर गलत बोल रहे हैं सही बोल रहे हैं। तो मेरा ये मानना है जो भी आए मन में लगे पूछ दो। यस सर, एक तो लगेगा। वो तो सही है सर, सही है। तब कोशिश करेंगे तब तो एक लगेगा सर, और एक फेंके नहीं लगा तो फिर तो चांस नहीं। क्योंकि अभी मेरे पास एक और क्वेश्चन है सर आपके लिए। ये डाटा देखने के बाद जो O2 सेट पॉइंट हम लोग मेंटेन करते हैं एज पर डिजाइन 3.5 होता है फुल लोड पे, और बहुत सारे प्लांट एपीसी ऑप्टिमाइजेशन और करने के लिए उसको 2.7 2.8 पे चलाते हैं, तो टेक्निकली ये कितना सही है? जरूर सर, ठीक है। थैंक यू एवरीबडी। और काफ़ी अच्छा लगा मुझे, तो काफ़ी कुछ जानने को मिला, और छोटा मोटा एक्सपेरिमेंट हम लोग भी किए हैं बट इतना डिटेल में नहीं किया हुआ है। तो लेकिन सर ने मुझे एक बोला कि खुद से करने से बहुत रिस्क भी है, प्रॉपर नॉलेज होने के बाद ही एक्सपेरिमेंट करना चाहिए। तो हम लोग भी कोशिश करेंगे कि पहले डिटेल स्टडी कर लें, क्या अडानी का इनपुट मिलने के बाद और भी हम लोग स्टडी करेंगे अपना, इसके फिर फर्दर एक्सपेरिमेंट हम लोग भी करेंगे। थैंक यू।
Thank you, sir. Thank you very much for sharing your thoughts. Now I request Mr. Plak Mukhabadia, Executive Director, BHL, to address the gathering. He has made the session very live and interactive by making a lot of positive, impactful intervention. But however, further we will be requesting him to speak. Dedi. I request our head of institute, Mr. Munish Jagri, to address the gathering.
सबसे पहले तो मुखोपाध्याय साहब को, त्रिपाठी जी को और हमारे सभी जो टीम्स गेस्ट आए हैं हमारे, और हमारे अपने जो सेमिनार के मेंबर्स ज्वाइन किए हैं, आप सबको धन्यवाद। आज सुबह से हम लोगों ने काफी अच्छे प्रेजेंटेशंस देखे और फ्लेक्सिबिलिटी क्यों चाहिए हमें पावर प्लांट ऑपरेशंस के लिए और उसको अचीव करने के क्या मोड्स हो सकते हैं, उसके बारे में हमने देखा। और जो दो सक्सेसफुल इम्प्लीमेंटेशन हुए हैं एट अदानी एंड एट दादरी, उसके बारे में भी देखा। सो whatever is required as per the regulation is not a dream. It is very much feasible. Keeping our operational parameters within the norms. BHEL has demonstrated it very effectively in Adani and in Dadri by Siemens. So the field is open, and now, and I think in the thermal sector, this will be the biggest business in next 5 to 6 years time, because by 2029, I think all the plants have to complete this flexibilization. They have to implement with 3% ramp rate. 3% ramp rate is more important. 40% load coming to 40% is not a big thing. Achieving the ramp rate is a big thing. So we have seen the technologies and this thing, and now we can take an informed decision. Our companies can take the decisions and move ahead in this direction. And I think that was the purpose of this workshop. And with these presentations, we could achieve some of the goals which we have set for this workshop. So thank you all for participating in this workshop. Thank you.
Thank you very much, sir. Now I request Mr. R.D. Katre sir to give vote of thanks to the participants.
थैंक यू टू ऑल। और रियली जैसे आप लोगों के बारे में बोल रहे थे कि जेएसडब्ल्यू के बारे में मुझे काफी लग रहा है कि हम लोग जो इतना करते हैं पीएफ बॉयलर वाले, तो आप लोग तो कैप्टिव वाले तो काफी ये सब फ्लैक्चुएशन आप तो बिल्कुल करते रहते हो। तो मुझे या डेफिनेटली आपके हाथ जैसा होता है कि वो जो लोड होता है वो एकदम सडनली थ्रो ऑफ होते रहता है, चलते रहता है। हाँ हाँ हाँ, तो वो जो आपका ये है वो रियली हम लोग को भी सीखना है कि आप लोग कैसे करते हैं। ये थोड़ा सा एक डेफिनेटली हम लोग ऑफलाइन बात करेंगे, उज्जवल से भी मैं बात करूंगा। और रियली वी आर थैंकफुल टू यू, टू JSW, देन अडानी टीम एज वेल एज हु आर जॉइनिंग ऑनलाइन। और हम लोग सब एक कम्युनिटी है। हम लोग ऐसे ही प्रोग्राम करते रहेंगे। और नेक्स्ट हमारा वर्कशॉप जो रहेगा इट विल बी ऑन 30th को शायद रक्षाबंधन आ रहा है, तो हम लोग शायद हो सकता है एक दिन पहले करेंगे 29th। एंड इट विल बी ऑल्सो क्रिटिकल इश्यू ऑफ द पावर प्लांट्स। हाँ, हम लोग कोई भी किसी एक पावर प्लांट के क्रिटिकल इश्यू पे बात करेंगे। Either it may be turbine problems or boiler problems or anything else. Yeah, it will be let you know, please. Thank you very much. और ये प्रेजेंटेशन जो रहेंगे वो हम लोग शेयर कर देंगे सबको, ठीक है। बस उसके लिए आप लोग आपके जो मेल आईडी एंड जो है वो थोड़ा सा दे दीजिएगा, मोबाइल नंबर्स। हाँ, get disconnected. Yeah. Online parts. And I request all online participants and thankful to them, and I request them to discontinue, please. This Varsha will over, please.
So please join for a cup of tea, please.
कोई दिक्कत नहीं है, प्लान बढ़िया चल रहा है। PC1 में चला हो तो DC पे चला हो तो